I mean, that's a whole nother topic to begin with, but
right, that's kind of where I was going. So, do you think there's
yeah,
actually people on it, or do you think it's just some sort of radio relay thing?
it will. I guess it could be people on there. What makes me think there's not people on it is all the fuck ups that they do. So that maybe there's people on it, but they don't live stream from it. They fake that part because for whatever, maybe it's too expensive or whatever reason. Because you see them like the hair is all weird, all the troll hair, like those little dolls, all the weird stuff they do with teleporters and like the toilet breaks and there's all full of all the shit. The station's actually full of shit.
Yeah. So they're moving that fast though? Because you said if they are up there, they're moving the speed they appear to be moving.
Yeah. As far as the speed thing, I think that has to do with that spiral graph. I think I can. Let me see if I got that again.
But the speed though, because we can see the speed, regardless of the path it's taking. I'm saying the speed itself, it appears to be moving at 17,000 miles per hour. It's fairly fast now.
Yeah, I've actually talked to Professor Phil with this, and he comes up with different figures. So it's hard for me to really think like, why is his figures correct when everyone else's figures are wrong?
Say his figures, if they're not 17.5, then his figures might be wrong.
Okay.
But he's a smart guy though, so I don't know.
Hey, Kosho, question for you. What do you think the odds of Newton claiming 17,500 miles per hour for orbiting objects to keep, or so that velocity to keep in orbit, and then all of a sudden in, the ISS is created, and what do you have it? 17,500 miles an hour.
Say about 100% chance.
So a guy.
It's right up there with the chance that you created a model and intentionally fucked it up.
So you're saying that the Newtonian or Newton himself, before the advent of electricity and technology, came up with that velocity speed, and just by happenstance, he's correct. You said it's 100%, right?
It's not happenstance.
It's happenstance.
100%. Yeah, okay. Just wanted to verify. You guys believe it 100%?
Yeah, it's not happenstance.
I don't know.
Not happen.
It's 100% according to you guys. That's what I wanted to know.
It's not happenstance.
Yeah, but
he didn't just guess a number and it happened to be right, like he was doing the lottery. What are you talking about?
So before the advent of electricity, satellites, rockets, missiles, he just got the number right, and all of a sudden he's right. Okay.
he had a pretty good estimate on the size of the Earth available to him.
Yeah, somebody was right about something. How can this possibly be true?
So how could it be right when you don't have a radius of 3,959 miles? How could he be right?
You assume that we don't have that radius.
Newton
it's
was
been
the
debunked.
guy. Newton was the guy.
It hasn't.
I falsified the curvature formula, guys, so yeah.
Guys. Lewis has been trying to get in.
Newton's the guy who came up with calculus and used that to determine orbiting bodies. You know that, right?
I understand how Newton came up with calculus for sure. But at the end of the day, before electricity, before missiles and rockets, the point is, gentlemen, you don't need
electricity to calculate the
Yeah, why did he need missiles, rockets, and electricity?
You don't have a radius of 3,959 miles, so it's game over for you guys. Nice job.
Okay.
Yeah, Newton.
Just assert that there's no radius.
Yeah,
just assert it.
Data.
So I falsified it. So when you guys come to the reality,
he falsified it by saying that the radius isn't true, whereas he predicted the exact number because he came up with the concept. And then it happens to be the true.
It's dependent on the 3,000.
That's more proof that the radius is correct. It's not the other way around. It's not correct.
It's dependent on the Earth being a radius of no larger than 3,959 miles. Remember, guys, Newton didn't account for refraction.
The Earth is, you idiot.
Newton didn't account for refraction, right?
You haven't debunked it. We know what the radius is.
I falsified the 1 foot 1 mile.
No, you didn't. No, you didn't.
Oh, yes,
This
I did.
guy-
Don't you?
You're in
This-
fantasy land. Well, okay, if you falsified it, So what you mean is you convinced yourself of something. Because saying it's falsified and our model is done and all the other crappy rhetoric that all you idiots insist on splurging out these days, that indicates that you have established something to be generally true, generally held to be true by everyone or by most people. And that has not happened. You are fantasizing. You have convinced yourself, your very gullible, very religious, zealotry self on this issue, of one thing. That's what's happened. Try and remember that. Don't present it as something else.
So just so you guys know, Newton didn't measure the Earth. He used previous measurements prior to people before him. And
oh my God!
If you look at what
That's
Aristotle's
ridiculous.
did,
Why would he do that?
How convenient.
That's my point, guys. Is that Aristophanes?
Everyone should start.
Supposed-
All inquiries should start
So
from the
are
beginning.
you going to interrupt?
What?
You're going to
Yes.
gatekeep me?
Well,
You're going to gatekeep
why
me,
are you
bud?
saying something so ridiculous?
You're going to gatekeep me, bud?
I'll put it. Yeah, well, we won't waste our time listening to your blabber. Of course he relied upon our accumulated knowledge of things. What do you think? Do you think that Newton was required to go and establish the radius of the Earth for himself, for some unknown, blithering flat Earth reason? Why is that required? I'd like an answer to this.
So Newton is a mathematician, correct, guys?
Yes.
Awesome. So when he relied on mathematics, he had to get them from someone else. If the mathematics are incorrect, which they are, that means you don't have 17,500 miles an hour in the skies. Try
Except
again.
we do. That's measurable. And you haven't.
How's it
established-
measurable, bud?
And we can
How's it
see the
measurable?
because
You can see
we can.
it. Okay. You can
I'll
see
tell
it.
you.
Yeah. Tell me.
I'll mute you. It's your idiotic attempt to block me out because you know you've said something stupid that you know already there is an answer to. We can measure it. We can triangulate to it. So we can see how fast it moves quite easily. Just see it moving overhead, know how far away some other place is, and see it moving overhead there. How is this difficult, moron?
So again, so you see it.
So again,
Hold on. Let me finish. Just clarify
Again?
what you just said. Hold on.
no. If you're saying again at the start of it, I don't want to hear it. I don't want to hear anything from you again. I only want to hear each thing once.
Why are you gatekeeping me, dude?
Because
You
you
just
fucking
asserted-
annoy me, and you're an
Yeah, you
annoying
just asserted.
cunt.
Yeah. You just asserted that you see it.
Yes.
And that you could use, hold on, and that you could triangulate to it,
Yes.
right? Would you want to run through the process?
Well, you see it, you measure an
Uh-huh.
angle to it, and you measure an
Okay.
angle to it from somewhere else.
Okay.
You use
So
this,
how do you
use-
how do you know?
You
it's
know the
same-
distance. You know the distance between the two places, and you know the 2 angles. You can
Uh-huh.
calculate the distance to the ISS. Can't
Uh-huh.
you?
And so how do you know it's the same object that's leaving that one position and coming to the second position? How do you know that?
Well, because it's
Lowered.
a recognizable object.
It's
Yeah,
a recognizable
and
object.
usually you do it where both observers can see it at the same time.
Right.
Okay, so basically your evidence is you can see it and you can measure angles
Yes,
to
yes,
it.
I
right?
believe things that I
Okay.
can see. I know how
Okay.
unreasonable that must sound
So-
to you.
So if
But
that's the case,
seeing something and measuring it is a
Yeah.
good reason to believe it exists. I think, don't you?
okay, awesome. So if you
Do you think?
see,
No. Let me just ask you. Do you think that being able to see something and being able to measure its speed is a good reason to believe that that something exists as described?
so if you're claiming to see it, that's fine. You're claiming to triangulate it, it's fine. But here's the thing: you claim to see a horizon as well, and you claim that that horizon is
We're not
physical.
talking about the horizon. Answer my question.
the
We're
horizon.
talking about the ISS. Let me
yeah.
repeat my question.
Let me finish,
My
boys.
question
Let me
is,
finish. Stop
well,
gatekeeping
no,
me,
because
dude.
we're not talking about the horizon. We're talking
Stop
about the
gatekeeping me.
ISS. Well, just answer my
horizon-
question.
The horizon is 100% imperative for your calculations the distance to and the velocity of the ISS. You need to have a radius
Why
of
is it?
3,959
Why
miles.
is it?
That's
Don't-
completely wrong.
It's-
That- if-
Horse.
Why is that true in any way? I've described to you the process. One person in one place on Earth, one person in another place on Earth. They both look up. They both see the ISS. They know the distance between each other. They measure an angle to what they're seeing. How does that involve the horizon or the radius of the Earth in any way? Go ahead.
Because when Newton calculated his 17,500 miles an hour, he had to rely on the radius of 3,950.
However, we aren't talking about Newton's calculation. We're talking about this triangulation of the ISS by two people on Earth. Now, how does this rely on the horizon? Go ahead.
Okay, so for you to be able to measure in triangles or in straight lines and angles, you need what?
A zenith would work.
So you need flat surfaces, right? So you can measure the angles to it,
No,
right?
no.
So if you're measuring your angles, you're measuring up into the heavens, but you don't account for what? Refraction.
talking
You don't
about?
account for any of that. And then on top of that, when you're measuring your angle, what are you measuring your angle? How are you measuring your angle? What are you using?
Measuring from zenith has nothing to do
dude,
with the
hold on.
shape of the
Hold
surface.
on, hold on a minute. We're not going to do this fucking Socrates shit, okay? If you've got a point to make the point. This is not quiz time for data. Don't do this.
Can I make a point?
The
Go
point,
ahead.
hold on, Crit. The point is that Newton relied on a 3,959 mile radius to get the 17,500 miles per hour.
And that has
point is-
absolutely nothing to do with measuring the
Stop-
distance
stop
to the
gating.
ISS.
Stop
So
gatekeeping
can we
me.
go back to the question that you avoided?
Why so triggered,
which-
dude? Don't be triggered.
Because I want an answer to my question, and you've tried to avoid it with this bullshit about horizon. So my question is, seeing something and being able to measure its speed, is that a reason to believe that that something exists as described?
I'll tell you why no, because you don't know what you're seeing. You think you're seeing something. Could there not be the same thing in two different locations? How do you know it's the
No,
how
no.
do you know
Because
it's the
it's
same
a single
object?
recognizable object that
It
can
is?
be seen
Okay,
traveling
okay,
around
so,
the Earth.
So here's
Yeah,
the
it
thing.
can,
There
it
are
can be
two-
seen
those
from
two
1,000
observers
miles
seeing it at the
apart
same
at the
time.
same time.
Two of them
Triggered.
have never been
Triggered.
seen. There's no reason to believe there are two.
So run me through the process. How are you triangulating? What device are you
No,
using?
answer my question.
You told me you see it. You can
Okay,
triangulate it.
here's
and
one
we can
here's one
triangulate its
example.
distance.
Yep,
And
I'm listening.
hold on. We already did the run me through the process. I already ran you through the process, and then I ran you through the process again. So you don't need me to run you through the process. And what we should be asking ourselves now is, why are you now asking me to run you through the process? Why would you be doing that when that's already been done? Is it because you're losing and you haven't got anything else to go with, so you just thought you'd flip back and have another go and see if maybe this time you'll find something within it that you can use to cast doubt? Since the whole refraction and Newton and we need a horizon to do it, bollocks didn't work for you. Go ahead.
Well, if you're going to adjust the using Euclidean, you know that Euclidean is limited to refraction, right? You can't use straight lines when you have refraction going on. Besides
Well, how
that
much
point-
refraction could there
Let me finish.
possibly?
Let me finish, please. So the reason why I'm asking your
What about
methodology,
artistic retard
let-
jumping in?
Yeah,
the reason why I'm asking you how you did it is because all you've brushed aside was that you use angles to it and two observers. So that's great, wonderful. You said angles to it and two observers. What device are you using to measure those angles? That's a very honest, straightforward question.
Well, I can tell you how one pair of people did it. One was in Los Angeles,
Are
and
you
the other.
white knight? Are you white knighting? I'm not asking.
No.
let him do it. Let him say, because
One person was in Los Angeles.
I'm not asking. you.
One person was in Los Angeles. The other person was in San Francisco, and the pass happened right between the two observers. It happened right between the two of them, and what they used was an accelerometer that was referencing a vertical plumb line, which you can do with any cell phone, right? Because cell phones have accelerometers in them that are very precise. and you can measure the angle of that object from that plumb line. You don't need to look at a horizon. You don't need to reference a horizon. You're referencing the plumb line that the accelerometer references. And you do it from the two observers, and you get two different angles of the triangle, of two different triangles, and you have of the triangle, and you know the distance between them, right? Because it's a distance that you could run, you could bike, you could drive, you could fly. It's a known distance, and so now that gives you a known distance and two angles.
Okay, great.
That will allow you to approximate the height of that allows you to approximate the height of the ISS, and you can even just say, okay, let's pretend we're on a flat Earth and not account for any curvature over those. Those two observers approximately 300 miles away, the object approximately 150 miles away horizontally from the two observers. You could pretend you're on a flat Earth. That it hardly changes the calculation much as far as the altitude of that object.
You wouldn't need any of that if you just did the zenith, like the doofus was saying. If you use the position that's right beneath the zenith of the ISS.
No, Jake's
right.
Any two locations that is at its zenith. Just measure the ground speed, and that's going to be.
In my example, that was to measure the altitude of the object. Now, if you just want to measure the speed, all you have to do is wait for a pass that's between two cities with two observers, and wait for it to go from one zenith to another zenith, right?
Okay, so just to clarify, gentlemen, you see it with your eyes. You can use a cell phone to measure the angle, and then you can observe the velocity of it between 2 points, right? Those are two separate things. One would be to take a measurement of its to calculate its elevation above the ground, and the other would be to estimate its speed, its ground speed. Awesome. So just to clarify, it's two zenith positions between two observers to analyze the speed, right? Right. And the other method to measure the angle to it is using a phone that has an accelerometer, which basically will tell you plumb to the horizontal, right? And from that plumb to the horizontal, you can get an angle to the ISS, correct?
Right. Has nothing to do with horizontal.
Well, that's what a plumb line is, right? Plumb line is perpendicular to horizontal.
Plumb line is just one direction. It has nothing to do with horizontal.
The plumb line is perpendicular to the horizontal, right?
Oh, the phone, it does an angle measurement that references the horizontal based on that plumb line, right? Because it's 90 degrees off.
It'll calculate that.
Okay.
But yeah, the plumb line is just a direction.
Run me through the math, boys. It's a 300-mile distance between the two of them. And what angles would they get? Would it be an isosceles triangle, right angle triangle? What triangle are we using?
About the altitude now, because you asked about the speed before. Let's
hold on, Kosho. Am I debating 4 or 5 people at once here? It sounds like it. Can I just? I'm not jumping around. I'm actually writing down your methodology and how you guys do it, so I don't have any mistakes. Okay. So far, you told me that if I have two observers and they're 300 miles apart, I'm going to measure the zenith of those two positions to get the velocity. That's the one methodology you told me. The other methodology is that if I have...
God, get on with it.
I'm just clarifying.
But you've just clarified. You've just finished clarifying. We don't need another clarification.
So to clarify again, what are the angle that one observer sees and the other observer sees to the ISS? You said you measured it using a phone. You just said one methodology is measuring it with a phone. So what angle would that be? Do you guys know?
No.
It'd be less than 90 degrees.
Who cares?
Oh, it's 90 degrees zenith?
That's what point are you trying to make?
I want to write down for the record purposes exactly what you guys think and how to measure the distance to the ISS and the here's
the video. Here's a video on it. Go and watch the video.
I've already watched
Go and watch the video.
I'm here to get it out of the horse's mouth, boys.
What you're doing now is you're just coming up with anything you can to keep waffling on about this, so that we can keep churning out more and more and more detail for you, that you can question every word, every phrase that's said, every little bit of it, that you can just keep yourself the center of attention just by asking questions about nothing. I haven't measured the distance to the ISS. I don't have a specific measurement that I'm referencing. I'm talking about the method that you could use to do this. And we know, for instance, at Red's Rhetoric, Scott Manley here has got a video on it. We know that people have done it generally. If you have a point to make about it, make your point. Say, I don't think this is possible because of refraction, because of whatever. But just this endless detail gathering, that pretending you're writing it down so you don't get it wrong, and it's ridiculous. And it's a game. It's a tactic, and it should bother you that your belief requires these tactics. Go ahead.
I believe
So-
that he's
Wait a second. It's my belief that no, dude. The point is I'm listening to you address your methodology. So as let's say if I'm coming in new and I want to be taught something, I'm listening.
However,
to
you're
how-
not coming in new, and you don't want to be.
Why are you
taught
gatekeeping me, dude? Why are you gatekeeping me?
Because you've hit on a good point. You are sea lioning. You aren't coming in new,
Okay.
are you? You aren't
So-
coming in new.
So if I came in and I wanted to ask you how you guys are
However,
doing,
you
which-
didn't. You didn't come in new, did you?
So I'm asking you guys how you determine it. You guys are providing that information with for me. So I'm making sure
Right.
that it's
and now,
correct.
And now, once we've told you it, you've tried
why,
to then
why
say
do you keep interrupting me?
because I'm pointing out that now
Dude, you're
we've
so
told
triggered,
you it.
buddy.
Now
You're so
we've
triggered.
told you it. You then asked me to run you through the method again.
That's
And
isn't that
I-
fair?
after I'd already done it
Isn't
twice.
that fair? Isn't that fair?
After I'd already done it twice. No,
you
it's
didn't.
not that. No,
You
it's not fair. No, it's not fair. It's not fair. It's not fair. It's not fair. Okay? I've answered the question that you asked 3 times. It's not fair. No, it's completely not part of an adult conversation. It's ridiculous. We've told you the method. You asked me to go through it. I went through it. Then I went through it again as part of my conversation. Then at the end of that, you asked me to go through it again. And since then, 2 more people have gone through it. And now you want us to go through it again. This is a tactic, Data. Why are you doing this?
Just like I did yesterday for you when I went to get my calculator and you ran away like a little bitch.
Yeah. Why
I
is
think
this?
it's just a tactic until we slip up, we misspeak, and then he'll just
Yeah,
attack that religiously. It's just a matter
exactly.
of biding time until we make a slip of the tongue, we make a mistake after repeating it like 5 different times. We're bound to make a mistake through the means of fucking mathematics, right? Statistically, we're gonna make a mistake. Like out of the 100 times he's gonna.
Data, do you think you're engaging in an honest conversation? Do you think we should just be polite and treat this as an honest interaction?
Here's how it appears. It appears when I inquire and I ask how you guys do it. There's a lot of uproar right away. Even if I come in, I say, "Hey, how do you guys?"
It was clearly
I finish?
explained to you though.
Can I finish, please? Just
Let him
chill out.
finish, because I have interrupted him a lot. I will shut up now.
I've been nothing but obfuscated, gatekeeping, and lockdown here, getting through the process. So I found out that you guys claim to determine the velocity, which is great. Now I've also found out that you guys can determine the height based on the angles. So I just wanted some mathematical numbers to see what you guys have done and what angles you've come up with. Now, granted,
Again, look,
hold on,
we
let me
haven't
finish.
done
I'm
it.
not done. I'm not done, dude. Just
God,
let me
why
finish,
is it so
man.
difficult for you?
So you haven't done it. Fair enough. That's what I'm here for. So they told me all this information, but they haven't done it. Great. We established that. Now listen, let's talk about Red Reddit.
At no point did anybody claim they had personally done it. Even if they had, you don't have any. You're not married to anyone here. You're not related to anyone here. It would just be some random person on the internet telling you that they have done it. We have told you about other random people on the internet who have done it. To you, this makes no difference. Doesn't matter whether it was one of us or whether it was somebody who isn't in this room. What matters is the method, as you know. And you've attempted multiple times to try and pull this method apart, and you've failed. And now your objection is it wasn't one of us that did it. That's ridiculous.
Okay, so
Nobody
again,
claimed it. Nobody claimed it was. What problem do you have
the fact that I get
specifically
so
with the method?
The fact I get gatekeeped here so hard is just priceless. But listen,
right,
I just wanted to find out
I've
how
got 2
genuine you
questions,
are.
Data.
There's
What
no
is it that
genuineness
you
there because you
currently
guys have
don't
not done this
understand about
calculation
the method?
yourself, right?
No, that's not true though. There's people
Okay.
in this room who have measured the zenith to zenith.
Okay. Kosho, run it through with me, please.
Oh my God.
I want to next.
Oh, we're going to run through it again, are
Can I-
we? Are we going to
so
run through
let
it
me
again?
finish. Let me finish. So,
It's a very easy thing to understand.
No, you need to say specifically what it is you don't understand about what we've told you so far. Then we won't need to run through the whole thing again, will we?
I mean, the
Can I
zenith
try?
to zenith thing is ridiculously stupid if you can't understand it. I mean, it's literally like the oldest way in the book to ever measure the average velocity of something.
Anything.
Let-
It's just
let-
the
hey,
location
can I
of the
try?
picture and the time it takes.
Hey, if I
So-
try to explain it to him, maybe it might work that way.
Oh,
Try.
No,
Go ahead,
this-
Crit. Go ahead.
This complete.
I think
this
Crit will do the best
complete dipshit-
job.
This
Just
complete
so
dipshit
dumb.
thinks that the existence of a contrary idea is equivalent to falsification. Okay? It's complete fucking moron.
Are you trying to divine thoughts there, bro?
No, it's just a fact of your position.
Well, I mean, what's wrong with the zenith to zenith measurement for the speed, for calculating the speed of the ISS? What is the problem with it?
You're asking me what the problem is.
Yeah, what's the problem with it?
Calculating the velocity of an object that you actually cannot verify the actual height to it?
yeah, I said the minimum.
Yeah, what difference does the height make? If it's directly over your head, the height doesn't matter, right? Because if an airplane flies over, no, it doesn't matter at all.
So here's
Why
here's
would
what
the
you
height
guys don't
matter in any
understand.
way, Kosho?
Here's what you don't understand. If you-
Over.
If you have two, I'll explain. No, you stop.
Let Kosho get in.
If you have 2
Don't
points,
need flat Earth data.
if you have 2
Just
points,
flat data. When I speak,
if-
it only takes 1 second.
if you have 2
Stop talking,
points,
dude.
you
Okay,
stop
you
talking.
can
If you
run
have
for
2
everyone after I
points,
tell this one thing to Jake.
okay, go ahead, try again.
Fuck's sake, Jake. Yeah, if you get the ground speed of the zenith position, then that gives you the minimum speed because you don't know the height at that point. That's what I'm saying. Is that you get at least the minimum speed it could possibly be.
Yeah, because the radius.
So, can I finish?
So the
Now I-
radius
now
at
I can
which
speak,
the
right?
ISS is orbiting, right? is
Now
going
listen,
to be,
gentlemen.
Yeah,
larger than the
yeah.
radius.
We're going to pretend that we're on a flat Earth though for this measurement. We don't need to. If we take into account the Earth, the slight increased distance due to the slightly increased radius, it's just going to be slightly faster. That's the only difference.
Okay, so gentlemen, if I have 2 markers,
Because it's traveling a slightly longer distance based on that elevation. But really, for this particular measurement, it's just like the same reason why if I'm measuring the speed of a plane, it doesn't matter if that plane is right over 10 feet off the deck over my head, or if it's 30,000 feet above me. We're going to get the same approximate speed if we're making that measurement.
Okay, so let me just clarify. Okay, if we have 2 markers and we have an object passing between those 2 markers, right? We don't know exactly the distance or height of that object, but we see it passing between 2 markers. Now, if an object's, we don't know its distance, we should be closer or farther, right? It will have a different velocity change if you don't know exactly the height or distance or the pathway of that object that you're measuring. In other words, if the object is closer to those 2 markers and passing, and let's say it's smaller, and then you have an object that's bigger but farther away passing between those 2 markers, there's no way to determine the correct velocity. Do you understand?
That's not
So hold
not
on,
true.
hold on.
That's
No,
not true.
It's
No, nobody's going to
That's
hold
not
on
true.
to you.
It's 100% true. So listen.
No, it's not true.
It's minimum speed. Okay.
No, that's not true. If you have 2 markers, and you're ensuring that if you're taking that observation perpendicular to the path that object is traveling, it makes 0 difference whether that marker is 1 foot away from you or 10 miles away from you.
It does, my friend. Try again.
How? How would it make any difference?
So
It does
this is
not.
what I mean. This is
He's
what I
saying
mean.
straight up. He's saying straight up. Zenith angle 0, 90 degrees above, right? Perpendicular. If you have straight up your vision point, and
Well,
then
he's trying to. Zanuck, he's trying to compare it to being on the ground, like a horizontal measurement on the ground.
Hold on, hey, Jake, a sec. So if you're looking straight up, and another person a mile away is also seeing that object and waiting till it's straight up, you don't need to know the height of it. That's what Kosho, that's what Jake are trying to say. You're wrong.
You make the caveat
again.
the minimum speed, we can cut this in the butt, and we don't have to keep arguing.
So
It's the minimum
I'm
speed it could possibly be. So it could be the exact speed, or it could be the small speed. That's it.
so I'm
We have
here
a
to-
super chat from JD who says ego drives these flat earthers to waste time. Ain't that the truth?
So
Yeah.
I'm here.
Well,
I'm
he's
here-
trying to compare.
Chat, JD.
what he's trying to do is he's trying to compare it to measuring cars or horses on a finish line, and you not being lined up with the marker, not being completely perpendicular to the marker. But if you're perpendicular, if you ensure that you're perpendicular to the path of travel on that marker, then it doesn't matter if the photo finish camera is 1 foot from the finish line or 1,000 feet from the finish line. If it's lined up perpendicular to that marker, you're still going to know which one crossed the finish line first at that moment. It will not make any difference.
Right, but that's a contention anyhow. So the one thing that you can say for sure is that it cannot be any slower than the ground speed. It cannot be any slower than it takes to travel that speed in the ground speed.
I'm here to document your guys' methodology and to clarify.
Go ahead and draw a diagram that explains if you draw a diagram that explains how an object that's over one person's zenith to another person's zenith, how the elevation would make any difference in the measurement. Please draw a diagram that explains this.
I already did a diagram right here.
What he's talking about,
I'm
Jake.
curious, Data. I took 10 seconds to make an MS Paint drawing, and you said like the height of the distance over a flat plane would make a difference, right? So
between your vision between the two markers and where you think the let me finish.
No data.
Let me finish. If you are looking up and just looking up, you have no other devices other than your vision, but you have two land markers. You're looking at an object travel between those two land markers. You're not going to get an accurate reading. Okay?
So look right here what I drew, right? You have 2 points. There's 2 different balls at 2 different heights above the 2 markers, right? And let's just say the marker they both travel to the marker on the left, and they both cross that line at the exact same time. Which object is going faster?
So I'm not looking at your thing. I have no idea what you're talking about. The point is,
we forget that he's blind and he doesn't actually want to look at the argument being presented.
Here's what the case is, gentlemen.
I would like you to look at what I drew. It took me a whole 10 seconds of my life, so please.
If you have,
he won't look at it. He'll just keep saying that it's wrong without actually explaining why it's wrong.
Yeah, he's got to add to his book that he's never going to publish because he's going to get scrutinized to fuckery.
Above you, and another person a mile away is looking at that object and waits till it's straight above him. It won't matter how high the object is to get an approximation for that speed. That velocity.
So you can get the velocity between 2 points of 2 observers looking up at zenith. I understand that. No argument there. I'm talking about placing 2 markers and analyzing a visual point in space and trying to measure between those 2 markers. You won't get an accurate reading.
Okay, so
the markers are the observer's data.
You don't believe it's that high.
That's if you're using 2 observers.
How high it is?
Data. The markers are the observers.
There is an argument.
One observer looking at the object going over 2 markers, whereas one person looking at one of the markers is obviously not going to be at its zenith. So what he's saying is completely irrelevant now. We're not talking about that flare data. There is 2 positions where
I'm looking at how you guys measure it in your minds.
Yeah, no one said that they measure it that way. You fucking moron.
What I live is in Kelowna. We have the ISS pass every summer. Okay, so I've done this already. So
why don't you just fuck off?
So I'm here to document what you guys say and what you guys think. Put it down on paper.
No, you're not
buddy. Doing it.
You're never gonna release a fucking book, just like Bib's never gonna do his test. All you want to do is come here and try to sound smart, and it's just cringeworthy to the highest degree. You even interrupted my flow when I was cooking my steak. That's how bad it was to listen to your rhetoric, bullshit, repetitive crap.
So I'm sorry you feel that way, brother, but at the end of the day, I have a book here.
All right, when's your book coming out then? We've been hearing about it for so long.
At the end of the day.
So when I actually
Japanese have a word itsuka, it means someday.
All right, someday.
When I feel that I've compiled adequate data and I address the arguments at play, and then I can highlight the incredulity, which that's what I'm here for, then I will publish it.
So you put in your book that zenith to zenith measurements can't measure velocity accuracy. I'm sure people will love it if it's in your book.
So check this out. The same principle, the same idea between 2 positions for the sunrise. Sunrise to sunrise.
Hello? This 2 flare data. Oh, he's been muted for some reason. But either way, I talked about this 2 flare data. I told you that the best to use zenith, not sunrise.
Right, we're not talking about something, observing something move between two markers. This is something that you've introduced. You asked us repeatedly for our method. We gave it to you, and this was not it. Go ahead.
So, again, two markers, which are two places.
Why are you talking about two markers? Explain to us why you've introduced this bogus method that we haven't spoken of.
Okay, so you guys told me two observers could be two markers.
But now you've got a third observer, haven't you? You've got your two observers and then someone observing the two markers.
Nope. Let me finish, please. You might listen to what I'm saying.
Hold on. Just let me say this one thing. The markers are the observers. Okay? There are no markers. There are just observers. Think of it like that. Go ahead.
Yeah, so like Kosho said, the same principle applies. If I have two observers at two different points, locations, and they both look up at 90 degrees, you can get the apparent velocity of the ISS. I totally get it. You can apply it the same principle as the sun. Okay, the same concept.
No, you can't.
Oh, you can't. So great. How come I can't?
No, you can't. You absolutely can.
Because
yeah,
I can. I can. So
no,
this
you
is why
can't.
now I can't, but yes, I can.
You absolutely can. Brian is a flat earther. He's saying he can't.
He's the flat earther, you idiot, and you can. Yes, go ahead. Data.
So I know you can. Okay, I've already done it. So I know you can have two observers and calculate either the sunrise or zenith if you want between the two locations to get apparent velocity. So listen. I'm just.
Why are we bringing in sunrise?
Just let him finish.
Crit, I'm just going to write some of this stuff down. You want to take over?
Hello?
Data, tell me what the velocity of the sun is from sunrise to sunset.
842 miles. I got one reading.
842 miles an hour?
Yeah.
And how did you calculate that?
You have two positions on land, and you have a sunrise between the two of them, or a solar noon between the two of them, and you time it out. So as soon as you have one observer measure the sun, as soon as the sunrise hits, which you can have a piece of paper up, and as soon as you're looking at the paper, as soon as you see the first glance of sun, you start the timer.
Right.
Then you have the other person who's 1,000 miles away, right? Have the same setup, hits the sun there. You end the timer. You get how much time it takes between the two sunrises over that distance. So you get it. Let me finish. Then you can also do solar noon between the two locations.
Solar noon is insufficient. You have to do zenith to zenith.
Wonderful, guys. Keep at it. So
I got a question for you.
What is the point? Is the zenith, dude? Like I don't know what you.
I had a question for you, Dad. What does the 800 something miles an hour prove?
That the Earth isn't rotating at a constant because at other two locations in a different area you have a different velocity of the sun.
Yeah, it's almost. Hold on.
Because you did it wrong.
Tom, no.
Fantastic.
Hold on. Correct. This could be correct because he's not. Hold on. No, shut up. Thank you. He's not accounting.
No, dude. If you don't know, don't answer because you don't know.
Hey, you don't. He does. He's probably not accounting for different latitudes, of course, resulting in different rotational speeds. Right? Or
no,
that is 100%.
No, he's just doing it wrong.
This is fantastic. No. Okay, hold on. Now latitudes. This is great. Latitudes, and I'm doing it wrong. So go on, guys. Tell me more.
Yeah. So when you're at a latitude, say at 30 degrees, rather than at the equator, it's not going to be rotating at 1,000 something miles per hour now, is it?
I don't know. You tell me.
It's not.
Have you done the test?
Yeah, I can do simple math.
Oh, so you haven't done the test, but you can do math. Okay, copy that.
Yeah. So you could. You could take. All right.
Just let Kosho get it in, dude. Please.
It takes long to say this. I've said this to you before.
Oh no, Jesus!
You can't do that, flare data. That's why you got two different speeds from two different locations, because measuring it from two different locations, from two different solar noons or sunsets or rises, you're gonna get different speeds. You have to be at the sub-solar point, the zenith, where it's at the zenith.
So to clarify, Kosho, I can measure the velocity of the ISS at 290 degree positions between two observers as long as I know the distance and I can get the apparent velocity. But I cannot do the same process with the sun, correct?
I just told you to do the same process with the sun, you fucking retard. Somebody else go ahead with this fucker. I just told you the exact fucking same thing, man.
See, all I have to do is get you guys to talk, and your incredulity just comes.
Well,
out.
it has to be at the zenith to zenith.
If
though.
you keep stating the problem incorrectly, you're still doing it wrong.
Tell me what it is. Tell me what I'm doing wrong.
I'll tell you exactly.
Zenith to zenith. We're not talking about solar noon, because solar noon is not zenith unless you're underneath the sun.
Right. So subsolar point is 90 degrees, right?
Yes.
Okay. So subsolar point.
No
is 90
shadow
degrees.
on the ground.
Yeah. So 90 degrees between two observers, but subsolar point between the sun is the same fundamental idea?
No.
Different? Okay. It's not the same. It's different.
Solar noon doesn't imply zenith.
It's at 90 degrees.
Specifically the subsolar point. Like, there'll be the solar noon at the subsolar point, but not every solar noon.
There's only one place on Earth on any given day where, or one path on Earth at least, where it would be solar noon and the sun would be at your zenith, and it will change from day to day as the sun moves between the tropics.
It goes along its cycle. Copy that. So in your guys' best estimate, sunrise is not possible, but the subsolar point is possible. How do I get the subsolar point between two locations if I'm not down in that location, down closer to the equator? Because if I'm up north, I'm not going to have an exact 90 degree.
Yeah, you're never going to have a sun at your zenith. You'd have to be between the tropics.
So under the same principle, is the ISS completely directly above you, or is it going to be off to an angle? So it has to be.
Yeah, it's not over the equator.
So hold on. So you guys have to be really specific and actually have two
the
observers.
sun moves between the tropics. The ISS moves further beyond that.
So
right?
hold on. So just to be specific, just to clarify,
in each direction, north and south.
51.6 degrees to be exact.
Awesome. So just to clarify, when Reds did his observation, was he directly under the ISS?
No, he didn't use that method.
Oh, he didn't use that method. What method?
He used a different method that was still entirely mathematically accurate as well, but he used a different method.
Would you like to run through? I know his method. Would you like to run through it, or can I explain it to you?
If you know his method,
I don't need anyone to explain
Tell
it.
you what, why don't you just make the point that you've got to make about his method? Don't bother running through it. Just say what
Everyone here knows his method. Everyone here knows it already. So if you've got a problem with it,
just be honest and say what you felt was wrong with it.
Exactly.
So I just clarified from your own words that to measure the velocity,
there's no clarification needed. Just make your point.
So you told me to measure the velocity, it'd have to be directly under the ISS to have two 90 degree observer.
We said that was one method. We didn't say that was the only method. We said that was one method, and a method that doesn't require you to do. Yeah, because it doesn't require you to do any geometry. You don't need to do any geometry to use that method.
Awesome.
That's why we mentioned it.
The other method is to use your accelerometer from your phone and match the angle you see with your eye, right?
That was one method. That was also not the method that Reg Rhetoric used, because he used the moon as a reference point.
So question for you, when you're using your angles based off the azimuth, do you take in perspective for account?
Oh, God.
Because you know that.
Why would you have to take perspective into account?
Perspective has nothing to do with an angular measure.
So you know the ISS is not actually going. The ISS is not going down, right? It's actually parallel to the Earth as it transverses over it, right? But it's appearing to go down. So your angle to it is going to be off, right? So
perspective has nothing to do with an angular measure.
If your angle's off to it, how do you?
I've never thought about that, guys. I think this guy's onto something.
How do you measure the height? How do you measure the height to it if that's the case to do the perspective?
Even a broken clock is right.
You don't change a fucking thing, you retard.
Oh, you don't.
This guy thinks Newton is an idiot. Let that one process for a second.
Newton stuck planks in his eyes, bro, and wrote 169 books on alchemy.
Yeah, Newton.
Yeah, anybody that makes cookies taste that bland is.
Hey, you know what's interesting is you can measure the height of a building from a long distance away by measuring the angle from the bottom of the building to the top of the building and knowing your distance from
you
to the building.
Thank you very much. You
Okay,
actually have
there's
to
no
know it.
perspective.
Hold
There's
on.
no perspective
Hold on.
needed into that measurement.
You just proved a point, which I want to highlight. You just said something very important when it comes to measuring angles. You need an actual tangible variable. Thank you kindly. Thanks for telling everybody. Thanks for telling everybody.
A single thing that was
Thanks
important this entire
Thanks
evening.
for telling everybody that you don't know how to measure angles to the ISS, because what you do need is the actual height to it.
No, you
Bottom
don't.
line.
No, you
You're
don't.
calculating the height. You have the tangible. No, you have the. Don't even do that. You have the tangible distance between the two observers. That's your tangible distance.
But wait a second. Wait a second. You're forgetting about refraction. The object is appearing to move down perspective, right? So the angle is not actually.
There's no refraction in this.
The angle's not actually there.
Refraction at nighttime. Refraction at nighttime.
So
do you know what
you fucking idiot?
This is why you can't measure things in the extraterrestrials with Euclidean, okay?
Do you know what's the clear and obvious? Do you know what's the clear and obvious debunk of refraction that the flat Earth likes to use to try and place objects in completely different places?
Uh-huh.
Do you know what the debunk is? It's the fact that you could take any go-to telescope that was built in the last 20 years, and you can plug in a bunch of variables in there, like your latitude, your latitude, longitude, the exact time. Some of them will even take your elevation into account. But it never asks you for the weather conditions, and you press the go-to button, and no matter how hot it is or how humid it is, it will point you right to that object. And you know what? That object can be very close to the horizon, as long as you're not within like a couple of degrees of the horizon where the real refraction is through the very densest part of the atmosphere. There is no refraction going on because that object will be perfectly centered in your viewfinder. If you've got a good, it will be perfectly centered in that viewfinder as long as it's not within a degree or two from the horizon. It'll always be perfectly centered in that viewfinder, which you would think
refraction's worst is. Yeah, the refraction's worst value is usually off by only a degree. It's usually way less than that.
So it's pretty weird that it will, and then by the way, from when it leaves that horizon, it will track it all night long at a standard state of speed, right? Which is the 15 degrees per hour. It'll do that, and it will stay centered in your eyepiece for the entire time, even though it goes from looking through the thickest part of the atmosphere near the horizon to the thinnest part of the atmosphere at your zenith. That object does not shift one tiny little bit through that 15 degree per hour movement.
So is it using straight lines then?
So there is no refraction.
So it's using straight lines, right?
You can measure the refraction by how much it deviates from where you think.
Hold on, Zenith. Hold on, Zanuck. So you're using straight lines, right? You're using straight lines to do it, right?
It stays centered regardless of the weather.
You're using straight lines, right?
You don't get it. Flat
so
data.
You're using straight lines, right?
Does it or does it not deviate? I'm confused.
Guys, will somebody answer this question about straight lines? And stop repeating yourself, Clark.
Oh, I love it, buddy. The incredulity is awesome.
The software assumes a straight line to that object. Yes.
Awesome. How do you get straight lines on a ball Earth?
What do you mean?
Don't be stupid.
What kind of a stupid question is that?
So, do you guys know the difference between?
So are you saying that if there's an ant on a basketball and you're holding an object over the ant's head,
so an ant on a basketball can measure curvature?
We're talking about looking at objects that are above the horizon. There's no
ant on a basketball measure curvature.
No, but people on the Earth can.
Basketball, okay?
Oh, but he's using an ant as an example.
Hey, if you
is a sight line and a surface line the same thing?
If you know any three attributes of a triangle, what can you do?
Once. This is great. Debating five at once.
If you know any three attributes of a triangle, what can you do with that information?
So you use straight lines on a ball. Can you explain how that works?
So if you know any three attributes of a triangle,
the answer was I'm an ant on a large ball. But then in the same breath, if I'm an ant on a large ball, how do you measure curvature?
How many attributes of a triangle are there? How many attributes of a triangle are there?
So now you want to reverse it on me, right? The point is you just
I don't think you know. I don't think you know the answer to that. To either of those.
You just proved that you
Hey, Data, you better answer Lewis.
You just proved you need straight lines. But how do straight lines work?
What are the attributes of a triangle? How many of them are there, and what are they?
I don't know. There's lots of different triangles, right? Isosceles, right angle.
Every single triangle has a set number of attributes, and they are all shared. Do you know what they are?
Segments, ratios, degrees, angles.
Yes, angles is one. What's the other?
Ratio. Ratio is how it works.
No.
You've got your adjacent, you got your tangent, you got your hypotenuse, you've got isosceles, you got right angle triangles, you got.
You still haven't said
there's another one.
Okay, I'll make it real easy for you. I'll make it real easy for you. Every single triangle has 3 angles and 3 sides. Every single one. And if you know, and here's the other question that I asked you before, if you know any 3 of those, what can you do?
Well, you can measure the distance to an object with it. You can measure the length, breadth, width of stuff.
Okay, the correct answer is you can deduce what the other 3 are.
Yes.
Sure, because it comes from a 90 degree, right? So if you have a 90 degree work, you can figure out what the other side is, right?
Degrees.
You don't need a 90 degree.
Well, that's how you get your
You
angle.
just need to know 180 degrees, bro.
You need a perpendicular to the horizontal to measure an angle to it.
Dude, if you give me a triangle, right, and you give me 2 angles and 1 side, I can find you the angle, like the missing angle and the 2 missing side lengths. I don't need a 90 degree angle to do that.
You don't need a 90 degree. Say it again.
I do not need a 90
degree angle.
How is this news to you?
How do you measure an angle without a 90 degree?
And then you can take
easy. Easy. It's called sine and cosine.
It's so
How do you
easy,
measure
bro.
an angle without a 90 degree?
Easy.
Run it through me.
What?
Yeah. So you don't.
You use a protractor, for example.
No, you don't need a protractor.
So
we have
protractor has a straight line, and it has a 90 degree, right?
I can do it with ratios. I don't have anything.
Oh, the law of cosines. Run it through me. The law of cosines, Kosho. Go ahead.
Commensurability.
That's not the law of cosines. SOHCAHTOA. That's just an explanation of your operation for opposite over adjacent or whatever, hypotenuse over adjacent, so forth. That's just an acronym.
Opposite over adjacent, moron. It's tangent.
You've got opposite over hypotenuse, right?
What?
You got
Opposite
adjacent over hypotenuse, and then you got
three of them.
adjacent over hypotenuse. You got
You got 'em
SOHCAHTOA,
wrong.
right?
You got them wrong. You got them wrong.
SOHCAHTOA is opposite over
adjacent.
hypotenuse.
What is opposite over adjacent? It's tangent, right?
Tangent, SOHCAHTOA. Let me write it out. SOHCAHTOA. Yes.
And then
TOA is opposite over adjacent. You've got- Anyway,
Those are the
you
3.
need a 90 degree to measure an angle, guys.
Don't
Sorry.
need a 90 degree.
You just told me
No,
your
you do
accelerometer put a
do not
perpendicular
need 90
your
to do trigonometry.
accelerometer put a perpendicular to the horizon to measure the angle to the ISS.
No,
Without
you-
that perpendicular, you wouldn't be able to measure the angle to it. Now tell me
Shut up.
again, how do you get the protractor to work without a 90 degree?
You don't need a 90 degree.
Well,
Look in the chat, Dana.
it has to have angles to it, right? So if you have a 90 degree, then between that 0 and 90, you're going to get an angle, right?
The 90 degrees simply makes it easier, so you don't have to use cosine.
Simply makes it easier. So at some point, you need measurements. You need a perpendicular to horizontal to get the angles, whether it's over 90 degrees or less than 90 degrees. You need a marker in the middle to determine the degree.
No, I could literally have you 2 points that do not.
Run it through me. We're going to measure
Holy
something.
shit.
Run it through me. We're going to measure something in the distance. How we do it? What do we do?
Oh, worth mentioning also, plumb does not depend on horizontal.
Plumb is perpendicular to the horizontal. That's what plumb is.
Plumb does not depend on horizontal.
Plumb is perpendicular to the horizontal.
Okay, but plumb doesn't depend on the horizontal.
Says who?
Says anything that you just hang by a string.
Gravity called.
Says anything you can hang by. Says anything you can hang by a string. It only goes in a direction. It has nothing to do with horizontal.
So if I didn't have.
I had to see him build a house on a hill.
So you basically when you have a quadrant, right? That's a string hanging down.
Okay, that wasn't weird. What happened there?
I want to see him build a house on a hill.
Can I just have one lane for 1 second?
Time's up.
Take the slow lane. Slow lane.
The globheads are reduced to trolls when they have nothing to refute straight lines in objective reality. Epic fail. Thank you. This room has been exposed.
No, I don't want a refund.
Put our panties back on.
No, I haven't got anything wrong with my PC.
No,
Can you guys repeat that again? I missed that.
Yeah, so I'm curious, right?
Read the chat, man. Read the chat.
So if we use the cosine rule, right? Can we not find the side or the length of one side? Even in a triangle that does not have a right angle.
Well, you need something to measure it off, right? So how are you going to do that?
Measure the what?
You need something to measure it against, right? So how are you going to do that?
Well, if you have two angles, right, and you have the distance between those angles, right?
So do you need a tangent between those two angles?
A tangent.
That's how a triangle is made, right?
Yes.
Okay.
So you have the length, right? You have angle A and angle
How do you
C.
have a tangent on your ball Earth? Is it because you're an ant trying to measure a large ball?
No.
Are you saying you can't put a tangent on a curved surface?
So you have a
You
curve,
can't
right?
use a tangent on a curved surface. You got it right. Yep.
Yeah, no, your aunt can't do it.
Really?
But I bet you my uncle could.
Yeah. You need
I
a
guess
straight
I'm
line.
yeah, so
How do
I
you
guess
have a
I'm
straight line on your ball?
easy.
Oh dear.
Oh, easy. What? You're an ant size, right? You're an
Yeah.
ant size, right?
Yeah.
That's what it
I'm
is?
gonna draw. I'm
Okay.
gonna take two. I'm
So
gonna
you're
take
an ant size, but yet you
Okay.
can measure curvature, boats going over
Yeah.
the edge. But you're ant
Yeah.
size.
Yeah.
You
so
need a
I'm gonna-
straight line. Where's your straight line on your ball, guys? Oh wait, you're ant size. I forgot.
It's a tangent line, man.
Yeah. So I'm gonna show
So
you
a
something.
tangent is a straight line, right, Kosho?
That's right.
Yeah. Awesome. So how do you get a straight line on a ball?
Dude, for fuck's
By
sake.
putting a tangent on it.
I'm not speaking, man.
Do I
Ask
do I have to
somebody else to answer
do I have to shrink to ant size to do it?
What
That's
the
what it
fuck is a
sounds
tangent
like.
line, man? What's a tangent line in
How,
reference to?
how
It's
do
a
you
straight
make
line.
a
Brain.
how do you make
It'll
a
match your brain if you do.
how do you make a sphere out of straight lines again?
This guy is fucking retarded.
It's really
Yeah. So
bad.
you
All right,
understand. Holy
He thinks
shit!
he
I'm gonna.
sounds smart. That's what's the funniest thing.
No,
about
don't worry. He's writing a book. He's got to be the smartest guy on the planet.
Yeah. Like I said, his book's coming out the same time Bev never does his test. It'll be here someday.
Oh, okay. This is getting real.
Data, why don't you go to your work and just tell people all of the great things you've discovered?
Dude.
So somebody
Mel knows Bev's never doing
needs
his test,
to
though.
demonstrate a
That
sphere
test
being
isn't
built with
shit.
straight lines.
Merle, the question
That's not. Hold on. I don't understand. How do you get straight lines with the
it's
sphere?
not built with straight lines, Merle.
So you can't build a sphere with straight lines, can you?
A tangent line is in reference to a curved surface. A curved
Right.
So is a tangent line straight, Kojo? Is tangent a straight line?
Not
though?
for a triangle, it isn't, you knucklehead.
A tangent isn't a straight line for a triangle?
Not for a not for a triangle, it's not
Give
curved.
anybody an example then, Grim, since you want to speak up. Give somebody an example of a triangle that happens to be a tangent line that's not a straight line. Tangent lines are straight.
Yeah.
No,
And
that's
then-
what I'm saying it is. That's what I'm saying, that it is
And-
a straight line.
And then show
It's
how the
only for
water
a
level
triangle,
test
right. But
shows
not for a
spherical
sphere.
water.
That's what I meant to say.
Here we go. So you can actually use the Earth's curvature, right, to calculate out a straight line between these 2 points, as I just posted here, right?
So you're using you're using curves. You're using curves to show a straight line.
Yes. So it is in this beautiful thing called mathematics, right?
So you're begging the question.
No. So in this beautiful thing,
Don't you have to show curvature first?
holy shit! In this beautiful thing called mathematics, right? You could take a given distance of a sphere, right? Or given difference.
So you're
of a
begging the
curve.
question. You're starting with a sphere. Noted.
Yes,
That's a-
I guess. Yeah,
that's a
I guess I
circle.
am.
It's
Yeah.
not
So
a sphere.
we're gonna pretend that this is a sphere, right? Just for simple
Grim.
mathematics.
So you're
Make
gonna
a circle.
you're gonna pretend for your
up, Merle?
argument. Noted. Copy that.
I just wanted to hear from you how the water level test proves spherical water.
Well,
It certainly doesn't
doesn't
disprove it yet.
What it doesn't do is disprove it. That's all I'm saying. And when he doesn't realize that every time he cuts his little level experiment in half, he's just creating 2 new level experiments.
Mm-hmm.
And the middle is still the middle. Everything is still the same, and he hasn't changed anything. So he's we should see water piss out one of the sides if there's a hump in the middle. He's just retarded.
How did Data get through his life?
Into how retarded he is.
Well, I guess part of the problem is we have this thing called gravity, and then we have a water level test, and we have geometry, and you can't build spheres with straight lines and horizontal lines, and that's what the Earth's covered in.
There's another problem, Mel. You're missing it.
It's like
You're missing it, though, Mel.
And you can put a grid of parallel and horizontal lines over the Earth.
New super chat coming in from New Bay gives Euro 99. All hail King Troll crit.
Okay. Thank you, New Bay.
Thanks, Lewis.
But you're also forgetting, Merle, that Bev's test exists on a whiteboard.
I've been like,
that's probably the biggest problem.
2 miles underneath 14.
So you guys don't realize that it can be taken off the whiteboard and demonstrated in the field.
I think there's going to be some variables there that he hasn't dealt with
You're
yet.
really kidding, right?
The prime problem is that the assumption is always being made that the Earth has no curvature.
Yeah, you autistic retard, shut up. The super chat takes precedence.
Which super chat?
Do I need to turn this guy up?
No, it's just you know how they say Rome wasn't built in a day. No one asks how did they build Rome.
Somebody just laughed when you said that.
Yeah, my mom.
Yeah.
It was kind of funny. I agree, but
what do you think Rome wasn't built in a day means?
It was built over 2 days.
The more interesting question is how did they build Rome?
Great time.
Right, and they
Constant
built it.
Down the hill
They didn't build it with lasers.
Yeah, but Rome wasn't built in a day means you can't get everything done quickly. It takes time and precision and planning and design.
It doesn't mean that Rome was built only at nighttime.
Yeah.
Man, this has been going on for 3 or 4 years now. Where did these?
If Rome was in the Bible, it would have been built overnight.
So, I mean, that's when you start to realize where the water level comes in and the grompers and all that good stuff.
Right. Well, we've got to get this test done, though. Maybe you should get on Bev's case about it because it's like saying, I've got a book coming out.
Right.
But you never actually
and when you put
a
water
page
up
down
against a horizontal line.
Oh, dude, it's like Brian from Family Guy, dude. Brian's always talking about that book he's writing.
So you put the water level against the horizontal line and it matches perfectly. So now what?
Hold on, let me just address something. Brian is much smarter than Data. Do not insult Brian. Anyway.
That's the problem, Earl. That's not going to show anything, bro. Jeremy says it best about using a ruler to verify the straightness of a ruler. It's not really going to, you're just verifying something that's in contention, so.
Yeah, let's use water to verify if water bends.
Contention? When has water been in contention? From the glob heads?
All other flat earthers that aren't you, they say water's not curving around the Earth.
Well, Bob says he's not a flat earther.
Yeah. Bev has this episode on his channel about the difference between hump and drop, and it perfectly describes his misconceptions about reality and what the sphere model is.
Yeah, he thinks they're two different globe models.
How's your cognitive dissonance going, Lewis?
Like these people are they're just fucked.
Yeah, Lewis's cognitive dissonance.
Merle, you were there when I tried to explain to Bev that he didn't understand the difference between drop and curvature. He kept muting me, and you guys kept on fucking dancing all over me and not letting me speak.
Yeah, but
treating me like
Grim,
shit.
curvature
there,
curvature
dude.
is
You know damn
measured.
well.
Curvature is measured by how sharply it drops. So what's the issue here?
Yeah,
that's the issue.
That's how far it drops from the horizontal line.
Curvature is literally measured by how sharply it drops.
No, from a horizontal line that
Listen,
you've created.
how do you measure?
above
How
the
do you measure a
horizon,
sphere? It's
that's
by how
correct,
fast
but
it
that's completely
drops.
different.
That's
Yeah,
how
I got
spheres are
No,
measured.
I'll
It's by how
explain.
fast they
I'll
drop.
show you. Here, I'll just send you.
You go look at the definition of how
It'll be a lot
spheres are
easier
measured.
for
They're
you in a
they're
picture
measured by
with
how
me.
fast they drop.
First of all, if you're measuring a sphere,
Like I
you know
said,
that it's a sphere.
curvature and
You're measuring
and
size.
drop calculations are two different things.
The whole drop thing is just a consequence of the curve. So it's a way to view that consequence of the curve.
But how you measure a curvature of a sphere is by how it drops.
There's a lot of ways to measure. You can measure all kinds of
also,
how you measure a sphere.
also too, you guys, Bev feeds off the attention. So like, if you want to talk about this like water level and measurements, I mean, just my humble advice. No one's got to take it. Just don't invoke the idiot, okay? Because he feeds off it.
So, M. Scott Veach, the trolls have reverted to DMing me this messages like this too.
That's Zebra.
Why does your what's it called? Font come in like that?
So if you've got two observers either side of a 10-mile wide lake, are they both seeing drops?
Oh dear.
They're both standing on top of the sphere, Brian. I know you want to go this route all over again.
Yeah, but are they both seeing drops?
Yep.
So it turns into, it has to turn into a hump.
Yeah,
then, doesn't
I
it?
saw right there in this new video. It was amazing.
He's measuring the drop, looking back and forth. You know,
They can't both have drops, can they?
and
Yes, they
We'd have
can.
like a
keeps going
pool
down
in the
from each
middle.
position.
See how
So he's
ludicrous your
measuring
model
stair
is.
steps, is what he says. The Earth's actually making stair steps downward, looking back and forth, and he's debunked the globe.
Your model is ridiculous.
I guess it's flat then.
Oh, Voight. Oh, Voight.
So did you hear them, Merlin? They said that I asked them how they get straight lines on a sphere. And then they used the example, well, you're just a tiny little ant on a big sphere. And I said, okay, how does a tiny little ant on a sphere measure curvature?
Yeah. Have they shown you them zooming in on a basketball yet?
All priceless, brother. Fantastic. It's priceless.
Yeah. I still don't know what you mean by how do you get flat lines on a sphere.
Straight lines.
Straight line.
They've got it ready, locked and loaded. It's good.
Yep, spheres can have flat horizons.
I love that meme because they deny their own science right there.
Negative.
Oh.
Well,
Because
first of all, you claim that that's a physical geometrical edge, but yet in your mathematics, you have to add in refraction, and then when you are presented evidence that goes against your geometric mathematics, you claim that the refraction is making the Earth look flat. But in the same breath, you're saying that curved lines are making it. But in reality, to get any kind of refraction, you need straight lines first. You get it?
We're not adding refraction. We are accounting for it. It is already there.
So you need straight lines for it, my friend. You understand?
No.
Oh, you don't? Please tell me more.
We're not adding refraction. We're not making it up. We're measuring the parts of the atmosphere that cause that kind of refraction. We know how light bends through density gradients.
Awesome. But you need straight lines to bend first, right? You can't have bendy lines bend, right? That's not how it works. That's not how refraction works. You have to have a straight line, enter a medium, and then it bends. You follow?
Yes. What's your point?
I don't think he follows.
No, that doesn't make any sense. Lines can just be bent.
No, your globe doesn't make any sense.
The light enters a differential medium with an angle of incidence. Big problem you had there with your description.
Oh,
I'm sorry. The refraction in the basketball
Refraction occurs
experiment.
when light travels through a differential medium and has an angle of incidence.
Sure.
Right here too.
Do you know how to get an angle of incidence, Zanuck? What do you need?
A tangent at least.
No, hold on. No, I'm asking Zanuck. I know the answer. Do you know what you need to get an angle of incidence?
course, an angle with respect
No.
to the differential medium.
You need a normal to the perpendicular to measure the angle of incidence. Thank you.
I don't. Measuring the angle of incidence, it just is an angle of incidence, which gives you normal.
How do you measure the angle? You need a normal to measure it off of. Yeah, you need a normal.
Refraction.
A protractor. Okay, keep going, boys. What else?
Done.
Yeah, keep going.
You're done. You're a genius. Done.
He thinks he sounds so smart. He's got
Is that
so
all-
many
is
Why do you think you
wrong.
need the normal for? If you have an angle, then you can figure out what the normal is at will or at your leisure, but you don't need it.
You don't?
No, you don't.
How do you get the angle degree then?
By calculating the angle, by using a tool to measure what the angle is.
Okay. And what tool is that?
You can match it with something that you know the angle for, like a protractor.
You can match it
How?
using a
Angle
protractor.
from what? Angle
I got-
from what?
I got an important question.
These guys are awesome.
It's really pretty simple. I don't know what your issue is.
It is pretty simple, bud.
Yeah. A lot of times what you can do, if you're using modern equipment, you're probably going to have some sort of picture of it in a digital space, and you can just draw the angle and see what the angle looks is by measuring that thing you drew.
Just draw the angle. Copy that. No problem.
I got an important question.
I got a question for you, dude. This is a little bit off towards a different
I
direction.
just said they had a question right before you did.
I didn't hear him.
My mic is coming a little soft, isn't it?
Yeah, a little bit.
If you can get a basketball to present as flat, why can't the Earth present as flat?
Because it's not.
That's the whole point of that meme, dude.
So the Earth does present as flat.
Dude.
The horizon presents as
No,
flat.
no. Here's what happens, Crit. A basketball can be made to look the same as the Earth in terms of its shape. That's the point.
So, in other words,
and the horizon can present as
in other
flat,
words-
but of course the horizon can only be there if there's curvature.
So
I
in other
think
words-
it's
so
I
in
think
other
it's
words-
very clear. I think it's very clear that
Fair enough.
the Earth does not look flat. It looks curved. It looks
another-
like a sphere.
So another way
Okay.
to understand it is to get a horizontal, you need 2 equal points of elevation, right? So in your ball, when you zoom in, you're showing 2 points of equal elevation from frame to frame.
Every single time you look out at the horizon, that is because the Earth is a sphere.
Okay, who's talking there? What's your
Every
name?
single time you see a sunset, that is
what's your
because
name?
the Earth is a sphere.
Sure,
That's
what's your
Lewis the Globe Seller. Lewis the Globe
Lewis.
Seller.
Lewis,
But you can't
I have
measure
one.
no
I have,
curvature, no?
Lewis,
Horizon
I have
drop.
one question. Lewis, I have one question for you.
I
Are
don't
you,
care.
Are you willing? Are you willing?
No, you're a fucking retard.
Okay, so you're not willing?
No,
We're here debating, aren't we? Why are you not willing?
no, you're here being a retard.
Okay, so you're not willing to be asked the question. Copy that. Lewis does not want to be asked questions.
I
Copy
know how to
written.
get hey data. All you gotta do is say ask him for a friend, and you can get around that.
Nah, it's fine. It's better to. I appreciate that humor though. It's good. But Crit, you had something to bring up earlier. I didn't mean to cut you off.
I think I forgot. It had to do with the super chat,
Yeah,
but the
that's
super.
it, Chris. That's what the basketball.
Hey,
Oh, no,
Crit.
it's, right?
Crit. Are you a voice actor?
I haven't done professional voice acting, but I do it for D&D sometimes.
Right. I heard the So thank you for exposing yourself. Finally.
What are you talking?
You said yes, man.
So Veach, do you bring the voice actors in, or what? Are they from Hollywood, or
About?
is that the new style?
You just
It sounds like it. Like Scott there. Scott Veach is connected into the.
Go Hollywood
voice
scene.
acting, gatekeeping team. of
So
voice
therefore,
actors.
I must bring voice actors into the Discord. That makes a ton of sense, guys. That's not paranoid at all.
It's not even NASA shields anymore. It's voice actors.
I know.
That's pretty rude. That's pretty rude. You just take away the
silly.
sovereignty that it belongs to Crit. You just
Yeah,
make
Crit
Crit a
just got called a
nobody.
shill.
So
I
Scott,
did.
Terrible.
I did.
No, he's a somebody. There's a
How are you
voice
gonna
connected to
hold
Crit.
on? Hold on, Crit. Hold on, Crit. Are you gonna take that? They just took your self-worth and said that you were paid to be here.
Yeah, the other one,
Are you gonna defend yourself on that one?
yeah, Kurt said he agreed with everything Merle said the other morning.
This is really
no.
what happened. Okay. It came from this morning when God Scalpel wanted to debate, but they kept shutting his mic off. So I offered him to go to Jose's channel, and he wouldn't do that. for some reason. So I said, how about if you go to Brandon's channel? He went to Brandon's channel, stayed there for a couple minutes talking to Don Gio and me, and then just rage quit and said I was working for Scott again. And
Yeah,
I'm like,
okay. I see.
don't know
I
how,
see.
I just don't know how to unpack that level of stupid. I just don't know. You know that
No.
that level
No.
of stupid. That stupid is so high and so deep that I just don't know. I'm stumped by that level of stupid.
High and deep stupid is hard to get by.
You just gotta
Can you
laugh at
prove
it.
that you're not
It's like
working for
Luke
Scott?
Skywalker in the garbage compactor. He needs the R2D2.
Yeah, so Dad, I gotta.
That's a great quote there. Turned off the trash compactor.
Radio.
Yo, Dad, I got a good chapter for your book here. If you ever get around to writing it, you there?
Yeah, tell me more.
Yeah, so I got my greatest proof of flat Earth or round Earth right here, right? It's called the gyro compass. Are you familiar with it?
Tell me more.
So a gyro compass is used to navigate ships, right? Because you can't use a magnetic compass when dealing with a large metal vessel, correct?
I don't know. You seem to be the expert. Fill me in.
Yeah. So when I was working with a shipping company and we were delivering goods from Florida all the way to Portugal, right? We had to rely on a gyro compass. You started off by aligning it to true north and true south, right? It
So
will always,
like a chronometer, right? But with a gyro in it.
yeah, it's a gyro compass. The thing that you run into an issue with in a flat Earth is due to the conservation of momentum on a flat plane, a gyro compass would not work at all, not in the slightest.
You got a demonstration.
Yeah. I got a little drawing showing what I got a little drawing if you want to look at debate chat box, right?
So your drawing is showing me the.
Yeah, I'm showing you the concept.
The drawing is showing me it on a flat Earth and a globe Earth, and showing me the difference between the two, or are you just showing me something conceptual here?
I'm showing you a concept here.
So you're begging the question again.
No, I'm not. I'm presenting you how things work, right? So if you take a look at a debate chat box, right, you'll see that the gyro compass, it's like the little circle, the orange circle, right, on the left, is aligning itself towards true north, right?
Yeah.
Are you
And if
assuming
we
it's
move,
on a flat plane?
yes.
Okay, you're begging the question.
Okay, cool. What about it? So again, like I was saying, right, it is aligning itself towards true north. However, when you move from my horrible drawing of Florida to Portugal, you'll notice that it's no longer pointing towards true north, despite them still pointing in the exact same direction as each other.
So what's true north? Is it the map that you're using, or are you lining it up to the North Star? Because when sometimes you line it up to the North Star, they do that as well when they do some ship navigating, right?
Yes.
Okay, so are you lining it up to your map when you say true north?
Purple X.
Yeah. A purple X
Awesome.
represents the location of Polaris.
If you're lining it up to your map, what error calculations are involved by doing map versus reality? Can you tell me?
Say again.
Data, have you ever used a declination diagram before?
No, we're not talking about magnetic compasses. We're talking about gyro compasses here.
Sure, but you're lining it to a map, right? True north?
No, you're aligning it towards Polaris.
Okay.
Why Polaris as a flat earther, though?
Well, as a flat earther, you would assume that Polaris would point towards north, regardless of where you are on the pizza.
Okay.
Why would you assume that as a flat earther?
Because that seems to be the
Polaris
central
was
point,
anything
right?
but a luminary.
So
Yeah, but it seems to be.
So it's refracted position, right? So you're taking in that effect, right? You're taking in that understanding. So if you move from location to location, are you understanding that if you move from one point to another, you're going to have different refraction effects? So it may not appear in that location when you go to another location because of refraction.
Yeah, but
by how much data?
Oh, I don't know.
Yeah, so the refraction.
So why mention it?
The refraction
Because
just
it's
kind
a
of
real
happens.
thing, bro. Refraction is a real thing when you're looking at the luminary.
If it's
Yeah,
an infinitesimal measurement, why bring it up?
Yeah, so hold on. So again,
Why bring up refraction? Because it's part
hold
of
on,
our reality and measuring.
data. I'm following you here, right? I'm following you for once, right? So even if refraction exists, right, it would have to change at the exact same rate that gyro compass just happens to be pointing, or changing its angle somehow, right? Which doesn't make a lot of sense as to why refraction would always seem to line up or change perfectly with how the gyro compass should be shifting on a flat Earth. Which would again would go against the whole conservation of momentum.
Are you saying that the equator is the central point?
The equator? No.
You sure?
Yes.
So the equator is the central point between the northern and the southern hemisphere, right?
Oh yes, that I'm saying.
So
Yes.
so it's the central point, right?
It's the middle point between those. Or
The middle, which is central, right?
No. So on there, right? Your central point is that is Polaris right there, true north.
No, it's not.
No?
No.
On that ball, right? I see. I
No.
marked it with a purple X. Really, really clear as day, right there.
But the Earth isn't a sphere. So the middle point is the equator. Right? It's the equator, right?
Okay, what about the equator then? If you want to call
That's
Polaris now
the
the equator.
That's the middle section, the central point.
Okay, what about it?
Right. So
You have a point somewhere.
That's where you have. Yeah, that's where you have to come back to. Like it starts with R.
What?
E, A, L, I, T, Y.
Yeah. Okay. Yes. The reality shows, right? The reality shows that as I move from Florida to Portugal, my gyro compass is always pointing towards Polaris, right? I want to figure out why that is, because given on this little pizza diagram here, with the conservation of momentum, it should be pointing somewhere totally different.
I think.
What momentum?
Are you?
What
You're
momentum
thinking
we
that
talking?
he's thinking that flat Earth is a flying space pizza, but flat Earth is generally considered.
Rocket.
Yes.
Flat Earth is generally considered geocentric, not heliocentric.
It's a flying dome.
Even in his picture, even in his diagram that he provided, he's making no assumption over the motion of the thing.
Yes. I am not assuming that the Earth is moving in the slightest, right? All I'm making is the observation that as I sailed from Florida to Portugal, the gyro compass always pointed towards true north, right? But as we see on a flat Earth diagram here, right? In order to do that, the gyro compass would have to fight against its momentum, which would go against the conservation of momentum.
The gyro compass is slightly more complex than that, though. Worth mentioning.
I know. So you have between 4 to 6 counterweights in order to fight the drift that you see on the X and Y. There is nothing keeping it from drifting on its Z-axis, though. The only thing keeping it aligned on its Z-axis, right? It's its own momentum.
Not completely. Gyro compass, yeah, it's locked to one axis, but the rotation of the Earth is what causes it to precess if it's out of alignment with true north.
It causes, yeah, if you're out of alignment with true north and true south, it will cause slight issues, right? But if you are,
yeah, it will shift back to true north. Yeah.
If you are aligned, if you properly calibrate the machine to be aligned towards true north and true south, you will not see any precession on the Z-axis unless the ship itself is changing angles, right?
Yep.
And that's what wouldn't that cause precession as well?
Yes, it would cause well, relative to you, right? The thing itself is locked right there at that position on the Z-axis.
But it still has to be
and it's the whole unit is mounted in a gimbal that can rotate freely, but it should try to keep the thing level.
Yeah. Yeah, so that's why you have between 4 to 6 liquid counterweights, right? In order to the thing you're having to worry about precession wise is its X and Y axi, right? Which are going to precess as either the ship moves or as the time of day goes by, right?
So how do you determine the difference between the Earth causing the precession or the movement of the ship?
So if you're sailing south, right, you're going to see a precession on its x-axis, right?
So is the ship causing the precession or the rotation of the Earth? How do you determine the difference?
You can't they are both like if your ship is stopped, right? You're anchored in port, or you're anchored somewhere, or you're waiting in line in order to get into a port, right? You're anchored out. You're still going to see a precession even when the ship is not moving.
So there's a mechanical precession, right?
Sailed.
Yeah. So no, I'm still going to go back to this point: is what force is out there that is keeping my gyro compass pointed towards true north, even when I change my longitude?
What force is keeping it aligned? Aren't you calibrating it to that position? And the whole purpose of the compass is to have it calibrated at that point?
Yes. Yeah.
So if you force it out of alignment, it always ends up back where it's going.
Yeah.
Because you calibrated to that point. So that's a marker. So if you mark it at that point and it falls out of precession either by the ship movement, which is most likely the case because you're under movement of the ocean. So the whole point is that it will eventually correct based. Yeah, they do. All gyros either have mechanical precession or velocity changes due to whatever motion they're being subjected to.
Yes.
They all have precession effects. If you have a marker, it will eventually go back to that marker. So it might take a second to correct the error or correct the precession for it. But at the end of the day, how do you determine the difference of Earth rotation or the velocity change of the ship?
Okay, what I'm trying to
Have
say,
it at a
right?
fixed installation.
Yes, you have your you have your direction, right? That happens to correlate perfectly with true north.
I didn't hear that answer. Can I have that answer?
Because you still never answered my fucking question, right? So you have your point, right? That happens to correlate perfectly with true north and true south, right? That is just a direction. You're not physically marking someplace on the globe and be like, hey, always point toward this thing, right? It just happens to be aligned, right? Now, as I presented with my little shoddy drawing again, right? You have your momentum, keeping it aligned towards a certain direction on its z-axis, right? Or its z-axis. However, when you change its location on the map, it's still pointing in that exact same direction that you aligned it to, the exact same angle. But when we see on here, it is no longer pointed towards Polaris because it is still pointing in the same direction you set it to in Florida.
Wow.
So what you're doing is you're looking at an angle in the sky, and you're marking that angle, right? No? How are you getting the angle?
You are setting the machine up, you are spinning it up, aligned at that direction, right?
So what direction?
Any direction you so choose.
Okay, so any direction I so choose, but you're trying to line it up to true north, I thought.
Yeah, you are.
Okay, so you line it up to true north based on your angle to it, which is based on perspective, which involves an extremely long distance and refraction.
Perspective.
Well, as has been mentioned to you several times, perspective is nothing to do with angular measurements.
It doesn't? How do you
it's just the angle going.
Yes, it really doesn't.
Okay. How do you get your angle? You have to look at it, right? If you're looking at it, you don't? Okay. So how do you get your angle?
Well, I could literally just plug it into the machine and it will do it for me.
Oh, okay. So you plug it into the machine. Okay.
Refraction doesn't.
But you have to look at the machine's readout, so therefore it's about perception.
Perspective does, but not refraction.
Well, if he's measuring the angle to it, if he's measuring the angle to it, then it would be an optical thing. But now he's entering the coordinates into the computer.
Okay.
If every measurement you use your eyes makes it an
You
optical
still
thing,
have
then
yet to
everything's
answer my
optical then.
question. You have still yet to answer my question as to the little shoddy drawing I made. What would cause the gyro compass to have to shift on its z-axis to the left?
Why don't you just tell us the answer?
Because I don't know the answer as to how this would work on a flat
So
plane.
I'd imagine
I'm genuinely asking.
I'd imagine how any gyro compass that I've seen work in action, there's the mechanical precession, then there's also the velocity precession or changes in the ship movement that will cause precession. So those are two variables that I would consider before it was Earth curve or rotation.
And you can just invert it, Chief. So you've got a globe rotating, okay? Now just invert that so the ground's not moving and the sky is just doing exactly what they're telling you the globe is. There's your answer.
That is not an answer.
That's not an answer.
That's your answer.
That's a retarded answer.
That is the answer.
That is the answer.
That's
Chief,
Invert
I
the
think
globe.
you should probably reassess your expectations for this conversation.
Invert the globe.
I have
Can you do it?
I have never been able to meet a flat earther who is actually able to answer this
Can
question.
a globe be inverted? Yes or no? There is a definite answer. Go on.
I mean, yeah, you could make a hollow Earth statement, right?
Right, so you can invert the globe, right?
I guess, yeah.
Right. So there you go. You're on the level.
Yeah. So
in all fairness,
still not an answer.
Yeah. What is causing? Yeah.
For the
So
record,
yes.
an
So we
inverted
inverted
Earth is
the
not a
Earth,
flat
right?
Earth.
We inverted the Earth, right? So now what is causing my gyro compass to precess on its z-axis?
The same exact thing.
All that's being inverted is what's moving. Okay?
Yeah. So we know mechanical precession happens, right?
And
velocity. So the sky's
ship.
Yeah, and the
ship
velocity.
changes.
So the sky's.
We know that the velocity of the ship also has something to do with its precession on its x and y axis, not its z axis. You would also have to explain how two different ships going at two different speeds, having the same model gyro compass, happen to always have their z axis aligned towards the same point, regardless of their speed.
Well, wouldn't it be the same effect? Wouldn't it be just lateral?
No, so if speed has something to do with the rate of precession, right? Then two different ships. Then two different ships going at two different speeds.
Nobody said speed like
the velocity.
It's just
Right.
any
velocity.
Okay, how about any velocity or any centrifugal force?
Also, just any change in distance. Any change in distance.
Well, there's going to be a centrifugal effect on the device, right? So if you're changing directions of your ship, why are you looking for all these other answers when you have two direct answers, which is mechanical precession, centrifugal force to the device, but yet you want this magical something or other, right?
You have still I can take mechanical precession, but you'd have to explain why mechanical precession seems to change all these gyro compasses at the exact same rate.
So they work on the same premise, right? So if you have
but they're different models. They're on different ships. Right.
Sure. Do they have the same velocity speed? Do they have the same RPM rotation?
No.
How fast do they spin?
The one I worked on had a rotation of 50,000 RPMs. Right. Others they operate on 60,000. Some of them they operate on only 20-something thousand.
Is it not possible, based on the velocity rotation of the disc, that you're going to have a kind of a common precessional error based on that spin speed?
Not on the z-axis.
Well, how do you know? How did you determine it's no?
We don't have to substantiate something you just made up.
Yes.
I didn't make up.
Right?
The fact is the disc rotation.
If you are sitting at port and your thing is still running, right, at 50,000 RPMs, it is not going to precess on its z-axis. It is going to stay aligned on its z-axis, which is what you are using to navigate. You are using its z-axis to navigate. And however, when you are docked at port, or you are anchored in, waiting to be accepted into port, or even in the middle of the fucking ocean and you're not moving, right? And that thing is still burring at 50,000 RPMs, it is not going to precess on its z-axis.
But how are you going to determine whether it's not causing precession, period, whether it's z, x, or y? How do you determine?
You see precession on its x and y, which you do not use for navigation. You use its z-axis, right?
The disc is spinning on all models. It has a velocity to it. So how are you separating?
The disc or the ball is spinning.
Right. So the deeper question is, so you've just all of a sudden appeared right when Noodle drops his info into a room fully equipped with the gyroscope knowledge. So, Veach, did you find this guy at the Quickie Mart? Has he got a script?
You really are paranoid, bro. This is the
He's
craziest
really
thing I've ever
just
heard.
like, it's just impeccable timing that this dude's just rocked in this room. No one knows who this dude is.
This is true paranoia with capital P, dude. I don't
So where have you come from, Chief? Let's hear a bit of the background story.
Yeah.
How you found
I've
the
been
room.
around for a while, by the way.
So how'd you find the room, Chief?
What's up,
How
Merle?
do I find
Are
this
they
room?
shutting
Well,
down the flat Earth? They got some shills.
So
in
how'd
here
you find the
shutting down
room,
the
Chief?
flat Earth.
Been here for he's been there like a year,
What's
Merle.
that?
I mean, yeah, Merle. He's been here for like a year.
What's that, Chief? I can't hear you, Chief.
Yeah, Alex. Holy shit. Right.
What's that?
Holy shit. So
Merlin, let me listen. I've answered your question. It's probably most likely just the precession of the disc and the movement of the ship, the rotation of the gyro. So now I've answered. I've answered
You didn't
your
answer my
question.
question.
I'm telling you right now, it's the mechanical precession and the ship's movement is causing the precession changes.
Okay.
So that's my answer. I'm going to stick to it. Now, can I ask you a question?
No, because your answer is wrong, and I'm going to explain to you why you're wrong.
That's fine. I'm okay to I'm okay to. It's fine.
Yeah,
totally
so
fine.
again,
At the end of the day, listen. At the end of the day, I'll never be convinced it has anything to do with Earth rotation. Okay, I'll be more convinced the fact that a gyro rotates. It's mechanical. It's subjected to a lot of variables, and one of them is not something I observe with this Earth rotation. What I do observe is the velocity changes of the ship. What I do observe is mechanical gyration, mechanical precession due to the gyro itself. That's just hands down what's in every single manual, every single thing that you have to calibrate and be aware for. Plus, there's also electromagnetic. Let me finish. Plus, there's electromagnetic interference. All these other things. I've answered it that way. Now, I want to ask you a question.
Okay.
Right? What's your name again?
Chief Squatting Dog.
Chief what? Chief what? Squatting?
Squatting Dog. Yeah.
Like squatty or squatting?
Squatting.
Okay. What causes the apparent junction of the sky and ground?
Say again?
What causes the apparent junction of the sky and ground? Earth curvature or your eyesight?
Remember, he said apparent.
Yeah.
I would say refraction. Refraction causes the apparent.
So, hold on. I don't hear Chief Squatting Dog speaking.
I'm going to stay on my gyro compass thing. I'm
Okay, so you have to stick to script. So
Exactly.
okay, my paranoia was not unjustified.
That's why I asked it.
So you have the script. What else is on the script, Chief?
What
to say when you're like backed up against the wall and about to be fucked like a dog?
Oh, so the reason why I don't argue with this thing is
one topic at a time isn't sticking to script, dude.
Yeah, because again, right? I want to talk about this, right? Because I was not satisfied with his half-ass answer, right? And also, I know better.
But I gave you an answer. So in fairness, hold on. In all fairness, I answered your question. Whether you don't like it or not, that's fine. Now I wanted to ask you a question.
I don't care.
So you don't care to. So just noted, Chief Squatting Dog doesn't care to answer the question. Noted. Thank you.
No, yeah, thank you. That's fine. You can put in your book. I'll wait for the release date. All right.
I answered your question.
Yeah. So and here's why I'm going to explain to you why you're wrong. Right. I already explained to you that it can't possibly be the mechanical the mechanical means of the gyro compass constantly causing a precession on its z-axis that just happens to line up perfectly, right, with where true north is. Right.
Do you realize the farther you keep talking, the fact that you don't want to answer my question and the fact you keep going on just makes you look that much stupid? You're already stupid as it is. You just continue to look even more stupider because I asked you a simple question after I totally responded to your question, dude. And then to be fair, you don't want to answer mine. So guess what, bro? You just move on, go on to something else because you just proved Merlin's point, my point, the whole thing. It's all blown open wide. Thanks again.
I don't think anything got blown open wide. I think the only thing blown open wide.
I
asked you a very simple. Simple question.
What it really looks like is you're trying to change the subject. Actually,
yes, I think so.
So did I provide an answer?
And you provided an answer deeper, and you're trying to change the subject.
So it's wrong. Okay, it's wrong. Now
let's move on. So let's try and find the right answer instead of trying to change the subject.
So you're here to make out that a gyroscope proves a sphere.
Yes.
So let's really dig into this.
Okay.
The pendulum shows that it's a sphere. Just a full pendulum.
No, we're gonna stick on a gyro compass because I believe that this is my strongest argument for why the Earth is round.
No one's gonna so try to make it short, man.
But yet you can't answer one question.
Really?
Noted, right?
So you've been doing this for 3-4 years, and you're trying to tell somebody else to make it short.
Yeah, I mean, we haven't heard the gyro truth of the globe yet, have we?
Just give him a chance. That way we don't have to talk about talking about it. We can just get it over with.
Right. So I explained to you how different model gyroscope or gyro compass is my mistake. Spin at different RPMs. They are comprised of different mechanics. And with these two variables, you would expect to see different results. As to the mechanical reason as to why you would see precession on its z-axis. However, you don't see that. They all seem to change at the same rate as the ship moves. Now we could take a look at the ship's movement that's changing direction, causing a precession. But of course, that would mean that's something it's fighting its momentum, right? What is fighting its momentum? What is physically changing the direction of its momentum?
The velocity of the disc spinning.
The velocity of so the disc is spinning then.
Yeah, it's the mechanical rotation of the disc causing the air.
Chief, bring the noise, bring the globe, wrap it up, dude.
Yeah, so
Hey, I wonder,
the disc spinning.
You guys actually measure the tides with that thing?
So the disc happens to be spinning at the same rate that my ship is moving in order to keep it perfectly aligned with true north. Is that what you're saying?
Data, don't feed him, man. Bring the globe, dude, with the gyro. Go.
Data, I got a question. Does that shit stay perfectly aligned with true north the whole time?
Yeah.
Hey,
it does.
Grim.
It does a really good job of it.
Hey, what's
Grim,
up,
we want the globe. So bring the globe. Let's go. Let's
Somebody
go.
bring the fucking globe.
Bring the globe.
Chop, chop.
Prove your ball. Let's roll.
Where's it? Well, come on. Give us the globe.
Yeah, so Data, I'm curious, right? So is the ship just happens to be moving at the exact same rate at which the disc is spinning? Because now I'm learning that the disc itself is spinning.
So you have mechanical precession.
Yes, we already threw that out because different models operate differently, but they all
Guess
show the
what?
exact same
They all precess mechanically. So if you
Yes,
have
they-
so listen, what is the
Not on
variable of
z-axis.
they all precession doesn't matter.
So if it
What-
precesses, right? If I'm docked at port, right, I should see a precession on the
Ask him why
z-axis.
they process. He's begging the question here.
I told
Why
him
do
it's
they
mechanical precession. He doesn't like
Why
it.
did
It's
they
all good.
process?
Yeah, so hold on.
The rotation of the disc.
The
Flash,
question
why do they
is, hold on.
process?
The
The
question
rotation of the disc.
is
Why
what
do
disc?
they process?
The rotation of the disc.
No.
What disc? The gyro compass?
The gyro disc, yeah, the disc that's inside us.
Okay,
It's spinning to keep the angular momentum steady.
Why does it
That's what
process?
process.
Right, okay, you don't know, do you?
Yeah. So if I am docked
Every
at port,
mechanical,
Don't
every
let him get off on this. Ask
every
him why it process-
gyro, every
Why does
gyro,
it process? Why does a gyro process?
the rotation velocity of the disc.
No, because if it's in space, it doesn't have any precession.
Oh, okay, in space it doesn't have any precession. Are you sure?
Yes.
Gravity.
Are you
say
sure?
Gravity.
Yes.
yes. So data. I got a
Too
question. Data.
Why
Data, I
does
got
it
a question
process?
for you.
Can you give the answer? You don't know,
Why
do
is-
you?
Disc rotation.
No,
Hold
disc
on, I got-
rotation does not cause precession.
It does.
There has
Xanac,
to be a force acting on it. There has to be.
No,
Friction.
the whole purpose.
Friction, you moron. Friction in the
Well,
pair
that's the disc. Doesn't the
precession.
disc doesn't the disc spinning cause friction?
No, this
It doesn't.
The bearings
Wait a minute,
cause
is the
friction.
seventh letter the alphabet
Oh,
letter?
okay. So
You can have a disc spinning in
so
space
wait, so
and have no
the
friction.
bearings,
You
the
can have a
bearing.
disc in space.
We're in space.
and have no friction.
Kosho, can you get some moderation happening, bro?
Speaking of time, let Dana ask his question.
Yeah, we'll bring him. Bring him. Xanix's jumping in.
Session.
Everyone's jumping in.
He has no idea what he's talking about.
So Chief Squatting Dog needs to bring the globe, Kosho.
Ask him a question. Give him a chance to
Yeah.
answer.
Oh, yeah. So I'm still waiting to hear why I do not see any precession on its z-axis. All right.
He
Whenever
said
I'm docked
Nazi.
at port.
Kosho, get him to bring the globe.
Oh, I'm just waiting for the answer for this, right?
Where's your globe, dude?
He already said a precession caused by the disc spinning. He's already got that wrong.
Yes, yeah. So he's wrong because when I'm docked at port, there is no precession on its z-axis. It is constantly aligned with where I set it to.
So
You
have the
said this was
velocity-
your.
Wait
Fuck's
a
sake!
minute.
You said this
Go
was
ahead.
your strongest. You said
Yes.
this was your strongest.
Yeah,
So
and
bring it. Bring
I
it.
am. I'm waiting for you to answer some questions, or at least come
No,
to some.
you need to bring the globe. Bring it.
We can get to it.
Hurry up.
I am bringing. It's here, dude. Like, hey,
Instead of asking no questions, just make
Brian?
a point. Because that doesn't like they want to answer any questions.
What do you want to know?
Yeah.
The driver's name is
Yeah.
Brian.
So something
Yeah.
So even if, right, the like he said
What
the
do you
disc
want my
with
name
the
for?
gyroscope. What the fuck are you? I can't hear you, dude.
So
Are you driving?
Driver's name.
bring the globe with your gyroscope. Go.
Oh, he's in a submarine.
In a submarine, which also use gyro compasses, which also don't process on their z-axis.
So how do you get a globe from a gyroscope?
By the mere means of its z-axis processing, apparently, right, in order to keep it aligned with
So
true north.
it's a reification based on an observation, basically.
Yeah, you don't get a globe from a gyroscope.
Yeah, you do. Because
no, you
he's
don't,
still
dude. You beg the question.
Yeah,
You're
no, I
observing
literally-
something. You're observing something. There's an apparent deflection there, therefore globe. That's literally what you're saying, bro.
No, what I'm saying is, if you take a gyro compass to a flat plane and you move the gyro compass, its z-axis is always going to
Do
be
you have a
pointing
globe? Do you
in
have a
the
globe and a
same-
flat plane? Do you have a globe and a flat plane to compare the two, or are you begging the question in both examples?
No, so I'm giving you a physics explanation.
I'm begging.
Now you're giving me a physics explanation.
Yeah. You're busted open. Busted.
Dude,
the gyro is like just rattled.
No,
literally, you're saying this. I see apparent deflection, therefore ball. That's literally what you're saying, brother.
No, there's no deflection. It points towards the same point.
That's what you're
which you would not
saying.
ex-
Just
which
let you
would
know.
you-
That's what you're saying.
Okay.
That's your argument. I see an apparent deflection, therefore ball.
Yes, and I have yet to hear you explain in some sort of comprehensible
I
manner.
already gave you
Yes.
why.
Yes, yes.
I actually gave you two scenarios. The
Yes,
the
and they're
velocity of
both
the ship. Sure. But again, I'm not begging the question. You are, so I'm not wrong. I'm saying that the ship is causing it because that's the movement of the ship. And I'm saying that the disk rotation is causing it. These are two known variables that affect the physical rotation of the
No.
gyro, which is, yes, it is. If you didn't know it, now you know it. The point of a gyro, listen, the point of a gyro is to keep rigidity in space so that you can.
Why?
Yes, it keeps its rigidity in space, meaning
Yeah,
that it's always going
that's
to
the
be
whole
pointing at the same direction, right? Or physical angle, right?
Not necessarily true. No, because you have
100%
mechanical
true.
precession. No, because
Mechanical precession
you
is
have
already
centrifugal forces. You have
Yes.
centrifugal forces
Keep
that
it
affect
blinded.
it. So
Yes.
listen, you want to reach out.
How
No, the centrifugal forces are not affecting it.
Yeah,
the boat changing directions, turning and banking. Are you
Forces
sure?
Yes.
Session.
Yes. So yes, the boat can change its direction all at once, and you're not going to see any alteration in its alignment on its z-axis.
My man, check this out. There's 50 people in here exactly. So you're gonna have to make your point and then give other people a chance to speak too, man.
And
There's
just-
other people trying to get
just-
in, there's other people trying to get in too, man. Just make
just-
your point and let other people speak.
Just for the record,
Thanks, Kosho.
just for the record, Chief Squatting Dog, the question that I've asked you is still open for an answer. So if you think you have a strong argument, then you should be easily and able to answer my question, considering you have a strong argument. Okay.
Mm-hmm. So we know that it's not I'll just wrap it up quick. We know that it's not mechanical because different gyroscopes operate on different mechanics, right? They have different bearings, they have different RPMs. So you would expect to see a different rate of precession on its z-axis, but they all keep their z-axis aligned in the same direction regardless, right? So we could look at the velocity of the ship, but again, distance traveled would put this thing pointing away from true north. But it does not prevent it from pointing towards true north. As I'll repost the diagram here, right? If we go from Florida to Portugal on a fucking disc, it'd be pointing in the wrong direction. Now, what is keeping it perfectly?
Okay, so that's
pointing the right direction to me.
So that's your argument, is that it doesn't point in the right direction, therefore ball. Is that correct?
No, I'm saying that it would not point towards the right direction on a flat plane, therefore ball.
Okay, so do you have a flat plane and a ball to compare and show me the results on both?
I could bust out the old gyroscope, right, and move it across my table and show how it will not be aligned. If I spin it up to be aligned with my switch that I have here on my table, and I move it 3 feet to the right, it's not going to keep pointing at the switch, right?
Okay, so just to clarify, your table is an example of the flat Earth, and then you're gonna use a like a globe next to it.
No, I'm just going to use the table.
So if you're going to use, do me a favor, when you put your driver on the flat table, put it on the ball too, and tell me how, as it transverses over the ball, tell me what results you get. All right, do that example for me. Post it. I'd love to see your video. In the meantime, are you willing to answer my question? Because I'm sure other people want to. You're not willing to answer it? Do you want to give me a reason why you don't want to answer it?
No, because I don't want to go down this rabbit hole of perspective.
I don't want to go down this rabbit hole of perspective. Copy that.
That's right. Yeah. Put
Okay.
in your chapter. I can't wait to buy the book. Or pirate it. One of the two. Probably pirate it.
Copy that.
Pirate it. Don't spend money on that.
Yeah.
That's pirate. Does it come in an audio book?
I'll just wait and catch it in its.
Yeah, I'll do an audio book too. I think so.
I'll read it to you for super chat money.
Sounds good, Crit.
Read it for the audio book.
Yeah, I would read it definitely.
Sounds great.
I got one question. Asking for a friend. When you took this boat from Florida to Portugal, how long did it take you?
You asked the best questions, Crit.
Did it take like a month or less than a month?
It took, if I remember correctly, it took 40 days. We were shipping drilling equipment.
What kind of drilling? What kind of drilling equipment?
It was a.
What kind of drilling equipment?
For oil.
What kind of drilling equipment? What was the company where the drilling equipment came from?
I'm not going to dox myself.
Sure.
You wouldn't.
This dude's punked.
Yeah.
Flat Earth data. Can you stop saying copy that? Listen, and stop pretending that you're writing a dumb book. You fucking mole. Can you copy that? Copy that.
What else do you want?
And real
I'll
quick,
put it
take
in
a
the
screenshot of all the notes that you took tonight. Like, and you're saying, okay, not answering the question. Like, right, take a picture, screenshot of that, those notes.
Yeah.
I'd just like to see it.
So you know what I'll do? You know what I'll do? I'll take a picture of my index, my chapter index. I'll block out what I've written. I'll take a picture and I'll post it for you just to see all the subject content. Okay.
Trolling and LARPing.
Because at least when I talked with Lemonbird about a year and a half ago about this subject, at least he had a semi-comprehensible argument for it, bringing in the aether, right? But you, not so much.
The luminiferous ether?
Yeah.
Right. So on script, guys. It's embarrassing.
Okay.
It is pretty cringy. Hey, I got a question for you, Merlin. Should I actually post the just on your recommendation here? Do you think I should post the indexes of it, of the all the categories I've written about, or should I just keep them hanging?
I'd keep them hanging.
So you know what I'll do? Can I trust you there if I send it to you just to verify? Can I trust you to tell them that it's there?
Sure.
Or yeah, okay. So I'll just send it to you a copy.
Nobody's interested in that, man. I told you it was exactly what I wanted to see, and if you're not going to post that, then so it doesn't matter. Merle, you can read it out, but it's not going to matter to anybody.
We're not allowed to ask questions. This is the world we live in. Just believe the authorities. Everything's fine. Nothing to see here.
So, Kosho, what voice are we going to get for the audiobook?
Me? What the hell?
Crit's voice. No, Merle's voice would be good. He can do impressions of everybody.
Yeah, but I'm the voice actor here, so sit down and shut up.
You and Merle can take turns.
Touche, Crit.
Did you change your name or something? I can't find you here.
Yeah, I'm Walter Russell.
What?
Walter Russell. Walter Russell?
Yeah.
Walter Russell. Okay, copy that.
That's his real name.
Yeah, the sound paper makes when you wrinkle it.
The genius.
Who is Walter Russell, Merle?
It should be Piper Russell.
Walter Russell is he was the dielectric. He's hard to explain. He was like an artist. He was a thinker. He was a philosopher.
Like Winston's dad or something.
Oh, he's sort of like pseudoscience, but not.
I got a question for the globalists here.
What's up?
If I claimed I could drink mercury and shit gold, would you say I'm a smart person?
Great question.
Ever said to me? No.
Like that's it, yeah. Because if that was my basically, if I died, right, and my relative said that he tried to drink mercury so he could shit gold, would you be like, that guy is the type of dude I want to follow with all his teachings?
I just answered you. If that was the only thing that I heard about you, the answer would be no. If there were other
Okay.
things that I know about you, it would depend on those other things.
Okay, sounds good. I accept that answer.
Taking a while to compress a single image to you. That's bizarro.
Dude, I think Brian from Family Guy will drop his book before Data will.
Well, the problem is, gentlemen, I'll be straightforward with you, is that there's a lot of information to compress and to compartmentalize. And so far, the stuff that I've handed out to friends and people, the thing is the only people that are really going to appreciate it is people that are in the circle, because they're going to be familiar with the argument. I'll give you an example. And this is also in the book. A lot of people that if you go up to them and you ask them how far away the horizon is, just out of curiosity, how far do you think the average person will say the horizon? It's actually at, let's say I did 20 people, they would be very close. Obviously off what the curvature calculator says, but they'd be very close within their own reality of what how far away the horizon is for them. But how far do you think they would say it is?
I might say 10 miles, 20 miles.
Kumbaya, my lord.
I think that would be highly dependent on who you're asking and what their frame of reference is. If you're asking somebody who lives in the mountains, it's going to be much different than someone who lives on an island and doesn't have
you would think that.
That's how he asked.
You would think that.
It's also
but I'm just-
irrelevant what they think.
So just saying that a lot of the content in this book is over the average person's head as far as the argument, conversations, and da-da-da-da. And I prove that with that one simple question, is asking how far the horizon is from them. So they'll say, some of them on average will say 20 to up to 40 miles. That's usually the consensus. So that's just the consensus. When you ask it, that's what people agree upon, right? They have a distance to the horizon, and once you tell them it's only 3 miles away, you should see the look on their face.
So
you can say so all you want. I'm just giving you something.
You can bring up irrelevant shit all you fucking want.
Yeah. So what you can do is go try it out for yourself. Just ask the layman person, a friend, or whatever. Hey, how far is
what
this?
does it matter what they think?
So again, the reason why I'm writing this book
All
is
right,
to
you didn't
document.
answer the question. Okay.
Yeah, it's to document this kind of stuff, right?
Yeah. I get it. You're a little trolley cunt.
That's it. That's all you got.
Well, that's all you've got, isn't it? Being a trolley little cunt.
So what I've done is gone out to the public and asked them questions.
What relevance does it have on the actual distance?
Oh, because it just highlights.
What relevance does it have on the actual distance?
It highlights a lot more than you guys are willing to understand at this moment. You'll have to read my
what
book.
relevance does it have on the actual distance?
It's none. I'll answer for him. None. It has
No,
no
I'm not
relevance.
asking you, dickhead. I'm asking him. What relevance does it have what people think the distance is actually on the distance?
Yeah,
because
The answer's none.
here's the difference is that I have you guys as an example, and then I have the other people that have their understanding of
And what
their
relevance
reality.
does that have on the actual distance?
So on the distance? Nothing.
On the
But
actual distance,
on the
yeah.
psychology effect of it,
No,
huge.
on the actual distance. I've asked you it about a dozen times now.
None. He said
So
none.
I already answered you.
No, you haven't.
Yeah, I did.
Well, if you had, you would have said none, because it has no
I did
relevance.
said.
Yeah,
I
he
did
said
say none.
he said nothing. Actually, I said none.
Fucking idiots.
You got two flat earthers
What it
telling you the
has-
same answer, and you still don't get it.
Shut up, Clit.
What it has significance is the psychological effect. That's the bread and honey.
And yet, it still doesn't change the shape of the Earth.
Oh, it does. Very much so.
Whoa, the psychological effects on people changes the actual shape.
Yes.
Yeah, dude, we're all reality.
You're a fucking retard.
Yeah,
I don't
so
think that you're calculating
so
in for the fact
tell
that
me-
the
tell me
environment
something.
you live in
When
is
you
going
measure
to have
the
an
horizon
impact on what your
drop
perception of the
0.04
distance of the
degrees
horizon is.
at 6 feet high versus 150 to 200 miles at 30,000 feet with a 3-degree drop. Tell me how that comports with your reality, your distorted, twisted reality of a flat surface beneath you.
I'm sorry. Say it again.
Tell me how a 0.04 degree drop of the horizon at 6 feet at 3 miles away, or 200 miles away, a 3-degree drop from 30,000 feet comports with your distorted, twisted reality of a flat Earth.
So you're asking me what angles of degree drop have to do with a flat Earth? Is that your question?
How do you have a 0.04 degree drop of the horizon? Do I have to say this 8 times? You should have
Yeah.
the first. You knew what you were
So-
talking about. You'd be able to answer the question quickly.
Yeah. So
How are
listen,
you-
do you have a
0.04
straight line? Do you have a straight line to that? Do you have a
tell
straight
you,
line?
a
Do you have a straight
0.04
line to that 3 miles, or do you have a straight line to that 200 miles?
You're talking. You're talking.
Zanuck, I'll have an answer for you. I have an answer
Last
for you.
time.
I have
Last
an answer for you.
Last
I have an
time.
answer
Yeah,
already.
Last
Guys,
time.
don't speak over each other, okay?
A 0.04 degree horizon drop at 6 feet, at 3 miles away, or a 30,000 foot elevation or altitude, seeing a 200-mile horizon. How does that comport with your twisted, distorted
Fantastic.
reality? of a flat
Fantastic. This is how it contorts. How did you get those measurements if you don't have straight lines?
You measure with straight lines.
Question.
Oh, so you measure with straight lines, but you don't
Yeah.
have straight lines on your ball.
Yes, we do.
Oh, you do?
Yes.
Okay, so welcome to Flat Earth then, because you can't have straight lines on a curved ball.
Where did you get that? Where did you get that distorted?
Oh, wait, no, wait. You can be an ant size. You can be an ant size to get the straight lines on a ball, right?
All right, just wait till the book comes out. You'll get an answer.
So if you're an ant, how are you getting measurement? If you're an ant on a big giant ball, how are you measuring Earth curve?
Airplane. And you use that navigation, you can see an angle to a airport, a open airport, green flashing light, repeating. You get an angle to that, and you can determine by your altitude above the ground how far away it is. And it all comports with reality of a curved surface beneath you, because you then realize you're exactly how far away you thought you were, and the horizon dropped 3 degrees because you're on a curved surface. You can't deny this.
How did you get the drop? You measured with straight lines, right?
You measure with a straight line, yes.
Right, but you don't have straight lines on your ball. Remember, everything is curved lines.
Why do you keep on saying that? Yes, there are straight lines on a curved surface.
Okay, can you show me them? Can you show me them? Can you show me this diagram? Can you show me using your? Can you
yes.
show me it? Can you do a diagram?
Hold up a level in an airplane, and that straight line, that horizontal, will be above the horizon, or even the sunset, or the moonset.
Right. So how are you getting a straight line on your sphere?
Dude, he's asking you about the flat Earth.
How are you getting a straight line on your sphere?
I just told you.
With a water level?
It's a stupid answer, Zanuck.
Water level, a heads-up display, a theodolite.
A heads-up display is not designed to measure off of anything, Zanuck. Why do you keep using a head-off display? It's not meant to measure anything.
Yes, it is. It's meant to measure the horizon drop.
Just the plane. That's it. Just the plane's pitch. That's all the heads display is
It's a
for.
horizontal that you can
The
count.
heads display. The heads display is
hold
not for
on,
measuring this Earth
hold on,
curvature,
hold on,
dude.
Hold on.
You guys are hilarious.
Heads up display. You follow that horizontal and never
Using a
ever,
water level, right?
stop talking. You can
That's
use that
clarifying.
horizontal
Using a water level.
ever go above a given altitude setting. Or if you follow the horizontal, you will increase altitude.
So you follow the horizontal, right? So we were on a plane then, like a flat plane.
If you follow the horizontal, you will.
So you're on a flat plane, right?
You don't.
You're on a flat plane to follow the horizontal.
The
right?
line is not on the plane, idiot.
The line is not on the. The line is not on the plane. Where's the line
is
not
not on the globe.
Is it a water level?
The line is not on the globe.
Anything is
Simple as that, man.
perpendicular to plumb. Anything that's perpendicular to
Hey
plumb.
Zanuck, I don't think I put you in this book yet. Now that I have you, did you want to answer the question? What causes the apparent junction of the sky and ground?
The curvature of the Earth.
Copy that. The curvature of the Earth. And that's your final answer?
Of course, it's the final. It's the only answer.
Okay. So what's the definition of horizon then?
Horizon is a point where things are obscured.
Okay, so the definition of horizon is the apparent junction of the sky and ground. Are you saying that your Earth curvature is causing the apparent junction of the sky and ground?
Of course it is.
Okay, so how do you separate perspective from Earth curve? How did you do it?
Perspective is just something going down in size, disproportionate or inversely proportional to the distance. That's it. That's all that perspective is.
Perspective is going down.
Perspective means things get smaller with distance, proportionally.
Right. So how do you determine Earth curve or perspective between the two? How do you do the difference?
Smaller objects has nothing to do with the Earth curve.
Okay, but how did you separate perspective from Earth curve? How did you determine the difference between the two?
Perspective for Earth curve. It's already a given.
But there's an apparent junction there, Zanuck. It's not a physical location. It's an apparent junction based on eyesight, right?
It delineates between what you can see and what you can't see.
What's being delineated? What's being delineated?
Means to be hidden.
What's being delineated?
What?
Sorry, I missed that. What was being delineated?
Between what you can see and what you can't see due to curvature.
Okay, so
the tangent meets the curvature of the Earth at a point, and that is
so
called
it's a
the
straight
horizon.
line, right? It's a straight line, right?
Yes. And
But how can you have straight lines on your ball? Everything is curved lines. Remember, it's spherical geometry, right?
When you say it doesn't make it right. Put it in your book. You're an idiot. I am an idiot, but here's what I'm going to say. You can't have straight lines on the Earth. No one says that except for you.
Okay.
Hey, Data. Data, can you see the text chat?
No, I'm talking
Can
to
you
Zanuck
see
at the
what I
moment,
posted
Princess.
at 38 seconds past?
So
That's
Zanuck,
something that you gave us about a year ago. Can you explain it?
Queen, stop spiraling. He doesn't follow
Can
the
you
text
explain
chat.
it? Shut up.
Stop spiraling.
Crit. I'm not
Yeah,
talking
stop
to you.
spiraling.
So Zanuck,
he doesn't follow the text chat. Stop spiraling.
So can you explain that? Data on the plane?
So
that equation
Zanuck,
that's in the text chat?
Zanuck.
No, Zanuck's not talking to you. I'm talking
Yeah.
to you. Can you explain that
Okay.
equation?
And who are you?
Can you explain Queen?
And who are you?
can call me Queen.
Queen. And how did you get involved fighting against flat Earth?
I'm not fighting
He's
against
absolute
flat Earth
monk.
because there's no fight because we've got photos, right? Mom.
So it's not
Can you
no
tell me
fight,
what
but you
that
sound
equation
you
is
sound
in the
you sound
chat
really passionate about it.
Came from you.
So Queen.
I'm passionate that you're a Hmong.
Okay.
Can you just explain that equation because the
Queen,
audience wants to know?
You're not fighting against
We're trying
flat
to do a
Earth.
professional program here.
You're not fighting against flat Earth.
Hmong data.
Because
Can you just explain it?
Not fighting against flat Earth
Can you
because
explain
you have
it, or is that a no?
not.
You can't.
I want to get. Hold on. I'll get
Scribble
there in
that
a
I
second.
posted at 38 past the hour. That was what you posted. That's some equation from your Mongy.
Yeah, you posted something about the observer's height. Square root of the observer's height times 1.22.
So he can't explain
What
it.
do you mean by that?
So data Mong,
What would you like me to explain? What would you like me to explain for it? What would you like me to explain?
If you have a look at the text chat, 38.
So why don't you
seconds
draw?
past.
Why don't you draw?
No, I'm not.
A
I'm
right
not the
angle
drawer.
triangle.
You're the
Why don't
drawer.
you draw a right
No,
angle
I'm not the
triangle and
drawer.
square the 6 root times it by
No, I'm not the drawing
1.22,
guy.
And you'll
I'm
get the
not the drawing
distance to the
guy.
horizon, right? But guess
Sure.
what, guys?
No, I just
Three
I just need you to
miles.
explain
That's
that
not a
equation.
that's not a reliable
can't?
constant. I just told you. I don't know if
can't.
you were
Thank
listening.
you.
So
Thank
would you
you.
like me to derive the math
Thank
so the
you.
1.22 came from?
Thank you.
I'll do the math for you. Would you
Data.
like it?
You can't
Don't
explain
run,
it
Queen. Don't run,
You
Queen.
can't
I'm
explain
about
the
to
equation.
Queen, don't run. Be patient
What's the
and
What's the
listen.
equation?
Okay?
Listen.
Square rooting the
listen,
observer's height
listen,
times
Linda.
times by
Linda.
122, right? Let's do in
Linda.
squares.
Listen.
Let's go in squares.
Listen.
Let's go in squares here,
Linda.
Queenie. You can't handle it, can you? When I'm
So
actually
can you
coming to
explain
bat to
it
play
for my
ball
maths
with
guy?
you. When I come to bat to play ball, you're running away, are you?
No.
Again,
She
draw.
didn't ask for you to do the math. She asked for you to explain the equation, you moron.
Thanks, Anonymous.
So you're having difficulties. So what did you need to be explained
so
to you?
explain the equation. Let's start at the beginning of the scribbled equation. Right? So we've got
I'm not looking
there?
at your piece of paper. Just tell me what it is.
D.
It says D times the square root of the height 1 times 1.22 equals D2.
Oh yeah. So that's a breaking down of the metric version of the 7,918 miles times 5,280 feet gets you 41,807,040. If you take that and you square root it and divide it by 5,280 feet, you get 1.22459, I believe. That there can be, you might be laughing, but it's true. Write it down, rewind and replay back what I just told you.
Yeah.
So you
Keep
take
going,
that.
Keep going. Explain the equation. Keep going.
So if you take that 1.22 constant and you square root it times it by 1.22, you'll get a distance in squares, right? You can write this down in squares. You
Right.
understand?
Yep. Carry on.
Okay.
Explaining. Yep.
So what you can
writing
also
it down
do,
in squares.
well, if you draw it in a chart form, yeah, you can do it little sections and little squares, right? You break it down in
Okay.
squares.
Cool.
So what's
Moving
the
on,
confusion?
what's the rest of it?
What's the confusion with the calculation? What's the issue?
Oh no, I just want you to explain your calculation. Can you not explain
Hold
that?
on.
So I just told you
Data.
where it derives from.
Data. Your formula
man.
doesn't account for a refraction.
No, it's not. Not at all.
Well, it does
That's
tell
why
you what the horizon is going to be. It does calculate. It's oddly coincidental that it tells you where the horizon.
It doesn't. It's an
It tells you,
approximation.
it tells you that the horizon will be at 3 miles, or it tells you it will be at 1.22 miles.
It's an approximation, but it doesn't count for refraction. You're right.
Okay, so just out of curiosity, you're claiming that the distance.
So it's wrong then. Thank you.
Place that
So
exist
it is
on
wrong.
Earth.
Absolutely.
Thank you.
But it's your calculation, numbnuts. That's the
Thank
best part
you.
about
Your
it.
calculation's incorrect.
It comes. Listen, you guys just proved
Will
your
I have
own
a
shit
chapter in your
wrong.
book or just a paragraph? Will I be
So
a full
guess what?
chapter?
Queen, you just proved
Where
your
about?
own
What chapter do you
geometrical
think you're
map.
going to put me in?
Queen, you
Chapter
just
1?
proved your own geometrical shit wrong.
3?
I hope you realize that
2?
because that information comes from your
What
7,908.
chapter?
Your 7,918 diameter is derived. That formula is derived from the 7,918 mile. So you just
You couldn't even
proved it
explain the
wrong.
equation, Data.
I just told you what it was. I just told you what it was. So you just said it's wrong because it doesn't account for refraction. Thank you.
So what
'Cause
chapter
guess
will I
what?
be in?
It's derived
Looking
from
forward to the
your
book.
curvature calculator. So guess what? You just made an idiot of yourself
guess
because
what?
it's from your shit, and you just said it's
what?
wrong. Priceless.
So guess what?
I hope somebody's recording this just so you know.
Oh, it's
that
been
formula,
recorded. Yeah.
Yeah, Queen. That formula is from your guys' shit, and you just
You're
said it's
wrong.
wrong. No, it's from your shit. It's from your shit, Queen, and you just said it's wrong. This is fucking great. My Columbo shit works all the time. It's fantastic.
Wrong.
You just proved your formula is wrong. You thought it was my formula, dude. I took it from your calculations. I took it from your guys' shit and presented it to you.
Is this the 1990s, dude?
I took your calculations and presented it to you. I took your calculation, presented it to you, and then you just proved it being wrong. Thank you so much.
Yeah, and you proved yourself stupid by taking Queen seriously.
Again,
That's not what
Queen
happened.
just said it was wrong, and everybody agreed with it, dude.
Dude.
Then data.
Queen, thank you so much. You just made my day.
What chapter will I be in, Dardamong?
Well, at this particular rate, I think your name's not going to be called Queen. That's for sure, because you don't act
What
like
chapter?
one. Number two,
Name the chapter,
you
Dardamong.
just proved your own mathematics wrong,
What
thinking it's
chapter?
mine. It's fucking awesome. Thank you for
How
that.
many chapters is the book going to be?
350 pages, maybe 400 pages. So right now, 30,
Really?
40,
How many
30,
pages
40
have you got
chapters.
so far? Is that in
Well,
crayon writing or is that using a ballpoint pen?
Well, for you, I can make it crayon if it's hard to read. You know, if you haven't passed grade
Well,
3
no,
yet.
I'm asking you. What are you
Right.
scribing it in? Is that difficult to understand?
For you, Queen,
Listen.
it's crayon. It's crayon for you.
Listen.
It's crayon for you.
Listen.
That's the only way you can read, Queen. But you know what? Thank you for
So
trying to come
how
out.
many chapters is it going to
Thank
be?
you thank you for coming out and trying to play ball, and you just struck out.
What
dude.
chapter will I be in?
Crayon for you. He just photographs the shit he smears on his walls for the rest.
It's so priceless. I described the formula for you. I tell you it comes from your mathematics, and
What
then you tell me it's wrong.
chapter will I
It's so
be
awesome.
on, Dardamong?
You got to come up with a better name than Queen, because I can't call you that.
Well, that's my
Dude.
name.
You said you derived it yourself.
So I used your curvature calculations.
I don't have a curvature calculator. Try again.
Again, it comes from your calculations.
Listen.
Data.
It's the best.
I'm not a
That's the
global
best part
celebrity.
about presenting shit. That's your own stuff, and you guys don't even know it. That's exactly what I'm doing here.
Listen.
Data. I'm not a glober. I've said this 1,000
Don't care what you are, dude. I don't care what you are, buddy. The whole
doesn't
point
care,
is,
dude.
here, bearded devil, write this down. Bearded devil, write this down. Okay, got a pen?
He likes telling people to listen and
7,000
write shit down, dude.
7,918
Dude.
times it. Queen, just be patient, please, sweetheart. I know you can do it.
Well, stop telling
So-
people. Stop calling people dude.
One
We don't
plus
have to do
one
anything
equals
90.
two.
Bearded devil, write this
Wait,
down.
1 plus 1 equals 2.
7,918 times 5,280. You're going to get 41,807,040. You square root that, divide it by 5,280. You're going to have a 1.22 constant come up. Follow me yet?
Well,
So
I'm
what
just
you-
curious.
So listen. So if you square root,
Yeah,
if you
hold on.
square root.
Listen.
So I'm just telling you. Listen. If you really want to know the math, bro, and how perspective has been hijacked and how that turned into a calculation.
I'm the wrong person to have an argument
Yeah,
about.
it's in my book. I show it through you all. I give you all the math. I show you how it's hijacked. I show you how it's turned into what it is. Done and
Cool. Where can we
and
get
the
the book?
best
Is
part
it on
about it is
Amazon? Where can I get this book?
you actually
Data.
presented it as exactly how I lined it up, and then you told me it was wrong, which is your shit.
I don't know.
It's fucking great.
Where can we get
Data,
this book? I'm looking on
just so you
Amazon.
know-
I can't find it. Book by Mom.
I
It's not coming up.
posted a copy for you earlier, Queen. You want me to
Oh,
repost it? Yeah, I'll post it again.
Definitely.
Hey,
Definitely.
Data, just so you know, you can click on people's names. If you see autistic retard, just ignore it. They're autistic retards.
Fair enough.
Listen, crit, listen.
There you go. I posted it again for you.
Okay, great. Let me check it out.
Hey,
Oh,
Merlin,
right.
are you still here, or Walter?
Flat Earth for
Walter
Dummies. Is that you,
Walter,
Dardamong?
oh, he's left.
This is your book?
I'm trying to.
Your book,
think
Flat
I'll
Earth
read
for
it.
Dummies?
Yeah, Flathers for Dummies. It
Tell-
was really powerful because it came,
From dummies?
Tell me more
Flat
about it.
Earth written by Mong Dummies?
So you know when you guys have lost, when you have no argument, and you just keep doing what you're doing. So thank you again.
Listen.
If we could get back to having a conversation.
So do you realize
I don't
Ko-Show
know
that
we
she
lost
insulted her
Corey.
own
I
math?
collectively that you're not worth the effort.
Do you realise, Ko-Show? You're sounding like a Karen, Dardamong.
Do you
You don't
realize
need to
that
tell
Ko-Show?
Ko-Show on me.
Yeah. Do you
Right?
realize that?
Listen.
Do you realize that they have no argument and they're sitting here and you're not modding this bullshit?
No argument.
I had
Here's an argument. Photos from space.
Triggered.
SpaceX. Photos from space.
Try
Videos
again,
from
Queen.
space. Satellites.
Try again,
GPS.
Queen.
What
Go
other
back to the
arguments
drawing
do you want?
board.
You just accused her of not having an argument, and now she's making an argument. You're just talking over.
Oh, so space photographs argument. Copy that.
Space
What else?
photographs.
Space photographs. Copy that. What else?
What's
what's your
photographs of
rebuttal on
space
it?
or
Satellites.
photographs taken from space?
Space
What's your
photographs.
rebuttal of
Copy
it?
that.
What's your rebuttal of the photographs from space?
Space photographs. Hey guys, what kind of cameras do they have in these?
What is your rebuttal of them?
No. This isn't for you to
What
ask
kind
me
of cameras
a
they
question
got
now.
on these satellites, guys?
What is your rebuttal
No,
of
this
them?
isn't for you to ask questions
What
now.
kind of cameras they got on them, guys?
Oh,
What's the
you
field
think
of
you're going to
view?
laugh and say a question you've won?
What's the bit rate? What's the bit rate in focal length on
What
these
is
No, you asked me
space
for
cameras?
evidence. I've given you evidence. Are you
Okay.
going to answer it, or are you going to?
So listen,
like
you've given me evidence, have you? Great. So please, this
Photos
evidence.
from space.
Awesome. You've claimed it's evidence. Now tell me what kind of cameras were on these. What kind of
doesn't matter.
cameras are being? It doesn't.
What
You sure
relevance
about
does that have? Can someone post
well
a
then-
photo of the ball?
Well, space.
Look at the photo.
Space has
and
some
tell
parameters.
me why that's not evidence.
Space has some parameters, dear. Didn't you know it?
We're not
Do you
talking about
think-
parameters.
do you think-
Stop deflecting.
We're not-
You're
we're
making
not talking
yourself
about
look like
parameters?
an idiot. You wanted to talk about.
So you're showing me a
evidence.
space. You're showing me a space
Right?
picture, but you don't know how the
I know,
space pictures are done.
I know what the parameters are. I could answer
What
that
are they?
for you.
Awesome.
There we
Tell me
go,
what they are.
Terry.
Yeah.
Well,
please tell me.
one is if you had a film, you have to wait till you get back to Earth
it's
to
film.
develop it. The other
It's
one,
film
and
in
the other one is
space.
if it was
Playing
a
a
film.
fucking
film.
game.
Even
It's
if it was
film in-
and if it was
it's
digital,
film
you'd
in
have to upload
space.
it.
Oh, it's digital.
Film in
Wait,
space.
it's digital. Wait, is it digital or film? Which one?
Film and space. Hey,
Well,
Data.
if you shut up while he was
Let
talking,
Terry
he was
talk, you
telling you
One
moron.
at a
that it was
time, guys.
two
One at a
different
time. I
I
can't
know,
hear you.
I know. I don't get a chance to get a word in sideways
Yeah,
sometimes.
it's all over you there, Terry.
So
You was a fucking wanker.
the satellites carry film noted. They also carry
Oh,
digital
No, Data,
noted.
this is time for you to be quiet. We're listening to
Yeah.
Terry.
Yeah,
Thank
yeah.
you. Go
So
ahead,
what?
Terry.
So film and digital is what they.
I think Terry wants to say something. It's true that he
Okay.
hasn't spoken at all tonight, man. There's something he's gonna say real quick.
Yeah, go ahead, Terry.
Oh, I can talk now, can I?
I
I've
don't
probably
know.
lost
Can you?
the point now because the answer. Am I talking?
I don't know. Are you?
Yes, you are.
Well, I thought I was.
Sounds like you're talking.
the two. No, I'm not talking. Sorry.
Go ahead, Terry. Good to go, Terry.
Yeah, looks like he put himself on self-mute. Self-censorship is the best type of censorship.
And there's the ball posted at 53 past the hour. There you go. Debate over. Thanks for playing.
Space photos, and she has no idea how they're done. Great. Incredulity at its
Fair.
finest. Thank you
It's
kindly.
been posted 53.
Appealing-
I go to
appealing
McDonald's.
to
I don't know how they
authority.
make the burgers.
You're
Does
appealing
that mean
to
I'm not eating a
authority.
burger at McDonald's?
You're appealing to authority. You have
Right?
no idea how it's done
No.
or compiled or put together.
Have
All
a
it
look
needs
at
for
this
you,
photo
all you
at
need for you.
53 past the hour. If you
Hey,
can't
Crit, do you have a
debug
photo
that,
of
debate's
Bigfoot?
over.
Do you have a picture of Bigfoot?
Thank you.
Oh wait, no.
I could.
I have a
I could
picture
do
of an.
one-
I have a picture of an alien
you.
UFO.
I
Right?
got a picture of a unicorn.
Yeah, exactly.
Hey,
Cool.
hey,
We'll
hey,
prove
why
that
are you
picture's not
tackling
real,
that
and we'll
word
start from there.
alien
So
UFO?
prove it
Right
is
here.
real, my dear. The
I've got
responsibility is
two
on you to
No.
prove it's real.
Data.
No, I don't need to prove
Yeah,
it's real.
dude. Yeah, dude. You do.
Check this out. I got a picture of a unicorn.
Data just got
and I have a
smashed.
picture
With a
of
photograph from space.
Destroyed
Yeah. Try again.
again.
You
I just told
embarrassed
you last
yourself.
time you were in here, Data.
You've embarrassed
Can
yourself.
I make a claim?
And now you're showing me a space
Listen,
photograph. You
listen.
have no idea how it's done.
Listen.
It's
Data
fantastic.
says listen. Mong.
Can
Try
I make
again.
a claim real quick?
Hey guys.
Okay.
Hey,
So
that
if
was
we
earlier.
were living on a
Hey, Queen, if you have space photographs, why are you debating flat Earth? You
Be
have
quiet,
win.
Data.
Why are you
Anonymous
here?
is talking. Stop being
Kinda-
a
kinda-
rude
kinda be-
mong.
It kind of be really retarded if you think you had that proof, but you're here
Shut
fighting
the
against
fuck
flat
up,
Earth.
you mong. It's
Stop being
my
a rude
turn to
mong.
speak, you
Oh,
moron.
triggered. Triggered.
Go,
So if
Anonymous.
we were living
She
on a
has
flat
ultimate.
Earth, then explain this. So if we were living on a flat Earth, you'd be witnessing different angles of the moon. And with the moon, you can't shout CGI because you witness the same pace every night on our planet. So place the moon on a flat Earth map, then you can place 4 people in a straight line in different little places, and they'd be seeing different angles of the moon. So explain that, please, because on a globe, we see the same side of the moon every night, and you can't deny that. On a flat Earth, you'd be seeing different angles if the moon was placed there. Can you debunk that?
Yep.
Okay.
I got it. Let me get. I got this one.
Okay.
I
All right. Go ahead. That was a good. I would have fun with that
So
one.
I see your vagina and I raise you vagina. Right here.
Okay,
you've got
Kosho,
Mary
he should be
Jo.
muted for that.
Right here, Mary Jo Smith.
Don't tell any girls
Just
in here.
no, honestly, just mute him for that.
Okay, so
He's
what I
just
got
been an
here.
idiot.
Yeah, I apologize. Let me rephrase
No.
it. You don't
No,
take my
you're
apology.
just being an idiot, and this is
Okay,
why
I
women don't come into the
apologize.
server because of mongs like you.
Okay, I
Say silly
apologize.
sausages and fuck off.
Yeah, I
How's that?
apologize. Can we move on? Offense was not offense was only taken. Offense was not given. Because I know a woman called Mary Jo Smith. She runs a flat Earth group on Facebook called
Answer the question
Under the
that
Dome
Anonymous
Photography.
had.
Yep, and right here you can
I
see
didn't ask for another person running something. I asked, explain how we can see the same side of the moon every night on our planet, but if it was placed on top of a flat Earth scale, you'd be seeing different angles. Answer the question.
Yeah, and there's two photos I posted, two of the best ones that you can get from this this Facebook group called Under the Dome Photography. And this is one run by a woman also. So you guys can't basically say that you're not letting women speak, because if you silence this woman, that would
God,
be
answer the fucking question.
Look at the two
Agree.
photos.
Answer the question, Crit.
Here's the best part about the incredulity. Can you show me your globe and flat Earth difference between the two?
Can you answer the question that
Or are you
Anonymous
begging?
had for you?
Are you begging the?
Data Mong?
I'm answering the question for you if you're
No,
listening.
you're not. You're asking another
So-
question. This is classic deflection.
So the
So you
incredulity,
want my models that I've made? No problem. I'll post him right now.
yeah. So can you show me a flat Earth versus a globe Earth? Or are you just assuming you're on a ball?
Answer the question, dude.
So I'm answering the question because if she
Dude.
thinks
If you
No,
can't
he wasn't.
answer, then it's obvious you're not fit for this kind of argument.
try harder.
Okay, this is now for you. Since you're not going to listen to me because I'm a man, you only listen to women.
Stick to the argument, man, or go back to flat Earth data. Stop
Yeah,
doing that, man.
right. Mary Jo Smith. She has a very large social media footprint. Instagram, Twitter, YouTube channel. She runs a flat Earth Facebook group. She's very easy to find.
Who cares? We don't give a shit.
Yeah,
I didn't ask about
Okay,
her.
ready? She takes pictures and she organizes these events where they all take pictures directed at the moon at the same time. She then plots these photos on a flat Earth conceptual map that she herself made, by the way. She has a map that she made. And then she lines these photos up.
Cool
and
story, Crit.
you can
Answer the
verify the story.
question.
I believe you. I'm looking at your pictures, and if you look at your pictures, it doesn't satisfy her problem. Her problem is that you should
That's
see different parts of the moon. Your picture shows people taking a picture of the moon and seeing the same side of the moon, the exact same side of it. Her
Tidally
problem
locked.
is I would see different sides of it.
How about the tidally locked?
Oh, she's talking about an object being above the Earth.
That's-
Two people looking at the moon, if it were close and local, they'd see two different sides of it. They'd see one side of it, the other people would see the other side of it. They're on two
Oh,
opposite
okay. I got this. I was trying to answer highbrow. I should have been
See,
answering
then
lowbrow.
answering the question.
Yeah,
So
just do the just
Yeah,
just do the
I
ceiling.
want you to
I
explain.
overthought the question. I thought it was a highbrow question. I didn't think of it as an idiot question. This is the observations of the moon predate all heliocentric models. There you go.
Oh, God.
No,
Okay,
God.
that's the best they got. Crit,
All observations
top
of the
5
moon-
flat Earth.
All observations of the moon, even when the Earth was thought to be flat and stationary by the majority of humanity, still
You're
exists.
not answering the question, Crit.
Yeah, all you
Maybe
gotta-
hand it
all you
over to your
gotta do is
mate.
go to a- all
Data
you gotta
Mong.
do is go to a library and check
Did
out the
you
history.
even look at my data and try to
All,
explain?
yeah, all you gotta do is go to a library and check out the history book, and you'll be able to answer your question. Just go to a library.
Yeah, okay, cool. So Crit's answer is
So
go to library,
you're
check.
telling me
That's
to go
going in the
to
book.
a library to answer my questions, but you can't answer them yourself,
I
Morgan.
tried to answer it in a very highbrow.
Can I just offer this for them? if you take
Data,
the,
do you want to jump in and save your mate who's
Yeah,
absolutely just
sure,
got destroyed
sure.
and embarrassed himself?
So question
for it.
for you: if I put a circular disc on my ceiling and I have a 6 and a 9 and separate 4 quadrants, and I place everybody in the room on opposite ends of that quadrant, will they all see the same number, or are they all going to see different numbers? If it's
What a
6, 9,
mong.
let me
What a
finish.
mong.
Let
So
me
you're
finish.
saying that
Stop,
explains
stop,
the
stop. Let me
complete
finish.
flip of the moon? I'm sorry, son.
Let me finish, man. So this is something you can practically do for yourself. Take a circle disc, put it in sections of 4.
Oh, we don't
put
need
it.
a sermon. Just get on with answering the question, Datamong.
Yeah.
Stop
Where's the
interrupting
point
me.
where?
Stop
Where's the point in the
interrupting me.
middle where it shows the ellipse?
Let me finish, man.
Try to keep it quick so people don't have the opportunity to interrupt you.
So if you have a circle, put it to your ceiling. Make 2 6s and 2 9s, north, south, east, and west, and have everybody stand on each side of the wall and look up. Are they all going to see the same numbers?
So you're saying the moon is flat?
I'm saying for the observation.
First the
I'm
Earth
saying.
being flat, and now
So
I'm
you're saying the
saying.
moon is flat?
I'm saying for an observation, that's as easy
So
as
you're
it
not
can
going
be.
to answer the
Yes.
question.
No,
Thank
that's
you.
a flat moon.
Thank
Do
you.
we have a flat
So
moon?
so you don't like the answer.
No,
but
no,
it
no,
That is a
explains.
flat
You don't like the
listen,
answer,
We
but it
have
explains
a flat
it. Okay.
moon.
You don't like the answer, but
I
it explains
asked
it.
you a question, and then you expect me to answer yours, but you can't answer mine.
Would you like
so
me to answer it again for
the
you?
question.
So again, you put a flat
So
circle
again,
up
we
on
have
your.
a flat moon, do we?
Let me tap in, Data. I think I got this. If they're stumped by
No,
flat,
you definitely haven't, Craig. You're better off to let Datamong answer it. At least he's got some chance of,
yeah, because if you're
making
stumped by
you look
flat Earth,
better.
you need to really go to a library and check out the history book because
Alright,
flat
cool.
Earth.
Oh my
Yeah,
God,
awesome.
I didn't
So
ask.
you're
How am
talking.
I
Hold on.
supposed to get-
He tried
Are
to
you
answer
going-
your question, Anonymous, with a 6 and a 9, as if it was spinning around. But what he fails to realize is that between the 6 and the 9 rotation idea that he's trying to come up with, which doesn't work, there would be a point where the moon would have to change shape, size, everything.
Would? Do you have a
And
demonstration
so
of that?
there's a point where also
that's
India
begging the
would be
question,
looking at
isn't
the
it?
back of the moon if it went
Really?
around on a disc
Let
like
him
they
finish,
see.
Data.
In my
What are you
example.
scared of? No.
So you
Let Sheeple
you
finish
have
his
to show
No,
where
I
that
don't.
turning point is. Yes, you do.
So
Rather than
bottom
the
line
simple
is-
observation.
The bottom
Stop
line is-
fucking talking.
It's a demonstration you can go see that offers you that explanation. No, whether the moon
Data.
is flat or not, it doesn't matter. It's
Data.
an apparition that you can't see the other side of.
Can we
he's
mute this
got nothing
cunt to
to
reply,
Oh
please? This is beyond fucking belief now.
I don't
He's
know
been
why I'm
talking
being.
through people for the last 2 hours.
I get interrupted
That's
every
his
turn, dude.
tactic.
I get interrupted every
Answer
turn.
the question, dude.
Ask him not to do it, but you guys gotta be careful not to do it too. But just make your point short.
Dude, they're walking all over every sentence I got. They walk over me. So,
Taking a long time to answer a short question.
You're not answering anything.
so I gave them an answer, and they're saying, "Is the moon flat now?" So that we're on to a second answer or second question. Are we? The point is,
Data.
let me finish, please. The
Answer
point.
what Sheeples. Address what Sheeples said to you. Address it.
Do
Stop
me a
skating
favor,
around and
Anonymous.
deflecting.
Do me a favor, Anonymous. Take a circle disc, put it to your ceiling, and walk around your room. You will see
Now
different.
answer what Sheeples
Why do
addressed to you, Data.
why do I keep getting?
Heard that explanation 3 times.
Okay.
You're
So-
making yourself look silly
so-
out here. You're making
Try again.
yourself look very desperate and
Yeah.
dishonest.
Again, you have no
Okay,
argument.
so
It's obvious.
address
You
Sheeples.
have no argument, and it's obvious. It's really pathetic that you try this angle. Appealing to humiliation does not work, dear. Try another
Address
tactic.
what Sheeples said.
You guys
Address what
appeal.
Sheeples said.
Listen, don't appeal
Oh,
to the
you
stone,
can't.
please.
Okay,
Don't appeal
listen,
to the
Linda.
stone. Don't
Listen.
appeal to the stone.
Listen,
Do not
Linda.
You're talking
appeal
about
to the
putting
stone.
a circle. Shut the fuck up, you fucking
Don't
moron.
appeal
Are you
to the
going to
stone,
let
ladies.
me
Mute.
Don't appeal to the stone.
Anonymous answers, please.
So, Anonymous,
You're
I
telling
gave
me.
you an answer. Yes, I gave you an answer. Take your circle
No,
sphere.
you asked me a question.
Take your circle,
Not
take your flat
even-
circle, put it on the ceiling, put different numbers on it, and walk around your room. The numbers will change. All right? That's a simple observation I can do to give you. If you don't like it, I don't care. The point is it works and it
Don't
explains.
like it, I don't care. But you didn't address
It
what Chico
explains.
said about that,
It
did you?
explains
I
the
use
different.
the actual Earth and the models that you flat earthers
Wait,
like
you're
to
using
use,
the
including
actual.
model
You're using the
There you go,
actual
talking
Earth
straight
or
through
the
a point
model?
again.
Do you
After we
even
heard
look
him.
at my fucking observations and analysis I posted in the chat, or are you just trying to ignore it because you're afraid?
Okay.
I
Can you
just
tell me
did
how that
not
proves
do-
Earth curve?
I'm sorry.
Oh,
me
he's
how
got to
proves Earth
change it
curve.
now. Get that,
Nah.
get that. He's startled
I
to
gave
death.
you an
He's gotta
answer.
change it now.
I gave an answer. You said now is the moon flat. Now you're onto something
No, you
about the
didn't.
moon bending.
No, you didn't. You
and
didn't
now,
address what
and
Chico
now,
said at all.
and now,
You're making
Anonymous
yourself
is
look an
back at
idiot
it.
out here.
Appealing to humiliation doesn't work. You're just appealing to the
You make
stone,
it,
my
well,
dear.
no, it doesn't
You
work
are
with you because you
appealing
have
to
no
the
shame.
stone.
Clearly.
Yeah, go ahead. You're appealing. Kosho, these
do that. So if you guys need to have a conversation like
these
or I'm just saying people and then get back to what I'm doing.
these
Forget about that. Please, I've asked you several times. I'm not gonna ask anybody.
these people are,
Wants to say something.
yeah, these people are appealing to the stone, brother.
Brother.
Okay, data. I will admit that if you put a 6 on a ceiling, looking at it from different points of the room, you will have a different number. What would happen if you put a 3D object onto the room and walked around it? And put
Is the moon 3D, or are you just begging the question?
So you're saying the moon is flat then?
I'm saying that you're begging the question, thinking it's 3D. We never see the other side of it.
Yes, I wonder why we don't see the other side of it.
3D, yes. Provable, yes.
It's provable
So-
3D. How so?
Because if you put
Contour
a 3D
lighting.
moon on
Contour
ceiling,
lighting proves 3D. Copy that.
Copy that. Good. Write that in your book.
There's a better example using what Data said. If you put a circle on the ceiling and you stand at the edges of the room and look at that circle, to every observer on the edge of the room, that circle will appear as an oval. It will be an oval to every observer who is not directly beneath it.
That's bullshit.
It's a mathematical proof. If you see a circle from every direction, from any position, you're seeing a circle. It's a mathematical proof that what you're viewing is a sphere.
So
Bullshit.
when I do it, I see a circled, guys. I don't see an oval. I've done it myself. I see a
Exactly.
circle.
No, in a room, no. If you measure it, you'll find that there will be
now
a
we're
major and a minor
measuring it?
axis to what you're observing.
Now we're measuring it? No, bro.
If you put a circle on your ceiling and go to the edge of the room and look at it from not directly face on to the circle, it will be an oval. From your perspective, that is perspective.
So again, I've done it myself. Go do it yourself again. If I have a ceiling 9 feet high and I've got a room 14 feet by 14 feet, it appears as a circle, my friend.
No, dude. Take a picture of it and then trace the shape of the object from the picture. It's going to be an oval every time. It's going to be an ellipse.
Those are like the base rules of perspective.
So
You're a
when
liar,
you look,
Data.
Yeah, when you look at this circle and you have a number written on it, the point is from each position around the room, the observer will see something different, which explains exactly what we see with the moon. Now, if we want to add in refraction, we want to add in some sort of projection factor or the moon's plasma, you guys think it's a solid rock. There's many variables in it. The point of the argument is that you can have the different number change based on that premise.
Wrong again.
Oh, you think so? Try it for yourself, brother.
I can do it right now with a light on my ceiling, a perfect circle light. I can see from
Oh,
here
okay.
that
So
the
you
one
can do it.
above my head is a perfect circle. I can
Yeah.
see the one in the distance that's the same type, exactly the same light fitting, is an ellipse shape. The one further away from that is further ellipse, almost like a crushed soccer ball,
So
rugby ball.
let me ask you a question.
You're a full of shit mongoloid.
Listen, if the ceiling is higher versus the ceiling is lower, so for instance, if the ceiling is low,
Hey, what's happening right now?
Tell me more.
Let me
more.
Let me finish. So if I have a lower ceiling and I'm farther away from that ceiling and I have a circle on it, it will appear elliptical. If the ceiling is higher and I'm not that far away from it, it will still appear to be circle. So you can try to deceive people, but at the end of the day, if the ceiling is high enough and the observer isn't that far from it, it will still appear to be a circle.
So data.
It's going to appear circle if it's at your zenith. That's the only place it'll ever appear exactly a circle.
Not true. Not true. You obviously haven't done it. So try again, guys.
Not only have I done
So-
it, I've studied math. Okay, I've studied math and geometry.
So again,
I understand
the circle doesn't become elliptical. It will only become elliptical if the ceiling is lower, really low, and the observer is really far from it. But if you are at the right, position, which means you're not too far away and the ceiling isn't too low, it will appear to be a circle from all positions. Yes.
You have to be exactly on an orthogonal axis located at the center of a circle for it to appear as a perfect circle.
So you
Any
can do that.
deviation from that axis
you can
will cause the circle to begin appearing as an ellipse.
If you have an observer at one position and you lower the ceiling with that circle on it, yeah, it will turn into an ecliptic.
No. I'm being very specific with what I'm saying.
Let me finish. But if I keep rising that ceiling up and up and up and up and up and up, eventually it will turn into a circle. So stop with your bullshit, guys.
So it will never turn into a circle unless you are directly on. Hey, remember when I stopped talking while you were talking? It's your fucking turn.
Try again.
If
buddy.
you are not on the center axis of the circle, no matter how high you get it, it will always be slightly elliptical.
Show me.
And the further you deviate from that axis, the more elliptical it will become.
Okay, so hold on. Just to clarify,
relax. Hey, Dad, relax. Remember, always to click on their name. If you see autistic retard, just step over that turd.
Do you understand that if I lower the ceiling, the circle will change into more of an oval shape? But if I raise the ceiling up, what happens to the shape?
Yes, your angle to that circle.
What happens to the shape?
The more increased your angle is. Can I finish the fucking answer?
I'm
Jesus
asking a question.
Christ.
What happens to the shape?
I'm answering the fucking question. I cannot get 2 words in without you fucking interrupting me.
Does it turn into a
You are one of the most obnoxious people who's ever come in here.
Don't care.
And if you still have a question when he's done, just ask afterwards.
The more increased your angle is to the surface of the circle, the more elliptical it will appear. But it will only appear as a perfect circle if you are directly on axis.
So more of a narrow angle to this circle, it will appear oval. What happens when the angle is not so narrow? What happens to the shape?
It will get closer and closer to a circle until you are directly on axis with it.
So we'll get close. No. Listen, you can go do this demonstration yourself.
Yes, I can, and I have.
Take a piece of cardboard, put a little circle in, and raise it up and lower it to your eye view. You will see it turn into a circle. Boom.
Yes, I've had to do range finding with cameras on calibrated objects.
Oh, so it's now it's
works.
range finding with cameras. Listen, brother, it's a quick and easy example to show that each observer from each corner of the room will see a circle that have a different shape or a different number on it.
So if you're trying to find your distance and angle to an object that you know is circular and flat, you use how elliptical that object is to determine your angle to the object.
Right. But we're not talking about that, are we? We're talking about different observers looking at a
circle. That's exactly what we're talking about. You're talking about a flat circle. If you observe it from any angle other than directly on axis, it will be slightly elliptical.
I'm talking about being able to see a circle, only one side of it, from different multiple views. You're talking about a flat circle. I'm not.
Okay, so the moon's spherical.
What shape is your circle then?
So it's round.
Yeah, but it's not flat. So is it spherical?
It's round.
Is it spherical?
He's fucking lost, man. He's lost.
It's round, and in this case, the round.
So round describes a 2-dimensional aspect of something.
Just to clarify for you, if I'm standing at one position of my wall, and I'm looking at my ceiling, and the circle looks oval, but I raise my ceiling, and I don't change my position of my observer, but I keep raising my ceiling. Eventually, if I raise my ceiling high enough, will it go into a circle?
It would become too difficult for your eyes to determine the ellipse, but it does not mean it is no longer elliptical.
Okay, so is the moon being able, or in this example, can I have 4 observers see the moon and see at different sides of the moon in this example if I keep raising my ceiling high enough?
They will all observe it to be elliptical in a slightly different direction.
Right, but it will look like a circle, right?
No, it will look like an ellipse.
Okay, so
you can measure it to be an ellipse.
Listen. This is you just basically are proving me right over and over again. If I have,
I think you don't understand the words I'm using.
No, I don't think he has a clue because he doesn't even understand what a flat circle is. I mean, that's what we're dealing with here, Taylor.
Yeah, let me finish, please.
Okay, is the moon spherical, Data?
It's round. So if
it's round,
if you have that object to your ceiling and it appears to be, like you say, oval shape, when I raise my ceiling up, will it change? Will there be a sweet spot for the observer if I keep going up, or would it just vanish out of my eyesight? Is that what you're saying?
It will get closer and closer and closer to a circle the further away it gets from you.
There you
but
go.
It will never. It will never. How about you don't cut me off in the middle of my sentence? But it will never become a perfect circle, no matter how far it gets from you, unless you are exactly on axis with it.
Right. Okay. So again, that's full of shit, because if I raise it up, it will turn into a circle, because if it goes into an elliptic based on an angle, then it will go to a circle based on an angle, because that's geometry.
Try fucking measuring it. That's not geometry.
Not trying to measure it.
I'm
just
specifically
observing it,
not
right?
geometry. The rules of perspective dictate that it can never be a perfect circle if you are off axis from it. Can never.
The higher it goes from oval to circle. You just said that, correct? And then you're talking about measuring it. But in the same breath, you already agreed with the principle that if it comes closer to the observer, it will appear to be that oval shape. And as it higher goes up, it will turn into a circle. That's all we need to know.
No, it won't. I did not agree that it will turn into a circle. I say it will get closer and closer to being circular, but it will never be completely perfectly circular if you are off axis.
So now we're talking
what
about
about
perfect
the
or
pictures
circular?
from NASA? All the pictures from NASA aren't on axis.
I'll mute that cunt.
Okay, this is completely
He's out talking to
relevant to what we're
children
talking about.
again, paying them to read shit. Get out of here.
No, you don't think that's a good point? I mean, this guy's saying it has to be on axis to be a circle.
No, we're trying to work out whether he thinks the moon is a flat plate or a spherical object, or we're trying to get that fundamental.
So the
understanding
argument
Nobody's
first.
been to the moon and measured moon's surface. You guys
We
all
don't
agree
need
it's
to go
flat
to the
on
moon
Earth,
to
though,
measure
right?
But you
moon's
can tell if
surface.
something is flat by observing it, a flat circle, if you observe it from multiple different positions.
Yeah, but we see all the same features on the moon from different observation points on Earth.
Yeah, and we
upside
never
down
observe
in
the
the
moon to
south.
be an ellipse, no matter where we are.
I never said we did.
Yeah, exactly. But flat Earth data is saying that we do. Or
That's why you shouldn't.
it's saying
That's why
that.
you shouldn't just jump in the
Excuse me,
conversation.
Let me correct.
Never.
Flat Earth data
I've never
didn't say
said
that.
that
I
at
don't think
all.
he said that.
Flat Earth data is saying that we shouldn't, even if it's flat, which is completely in opposition to the rules of perspective.
No, that's not what I'm saying either, dude. Never. The argument was this: can observers in different locations see different sides of the moon? And then the example I have, yes, if you have a lower ceiling, your circle that you put on there will appear to be oval. But if the ceiling is high enough, it will turn into a circle, just like you said. But you said it won't be a perfect circle, but nonetheless, a circle.
Yeah, and you can measure that it won't be perfect.
Listen, I got it. But at the end of the day, it's still a circle, and it's still allowing the observers to see different sides of that circle. That's the whole point of the argument. If you want to get into the finer details, sure. At the end of the day, high enough ceiling, at the right location of the observer, it will appear as a circle. If you change that angle, lower the ceiling, or farther away from the observer, it will take the circle and turn it into oval. I get it.
What we see with the moon? Is that what we see with the moon? Ever?
What do we see with the moon?
Do we ever see an ellipse to moon? From anywhere? From any orientation?
I think at the end of the
Take
day,
your time if you need to.
We're seeing a round object. But that's not the argument, is it? The argument is, can four different or multiple observers see a circle from different points of view and see that circle have different sides to it? And the answer is yes. And how is it demonstrated? Well, that's an easy demonstration. Done and did. But now you're trying to
explain the moon. Remember the question originally? Remember what you're trying to answer, or did you forget?
So again,
well, but also your
Did you
demonstration
forget?
didn't show it.
He's on point.
Be honest. Did you forget?
I repeated
Be
exactly
honest.
what we're.
Be honest now. Did you forget the question?
You keep interrupting him.
100%.
He's answering your question.
100% I'm on point. I'll tell you why. Anonymous asked me, how is it possible to have all these observers around Earth see different sides of the moon? And I gave her a
Wrong.
Okay,
Try
it's
again.
wrong, is it? So that's not the argument? I don't think you were listening, bud.
It was phases.
Oh, now it's
Same
phases.
face. Same phase. Same phase.
No.
Same phase. Not
phases
the
or
other side of the
faces?
moon.
No.
Why don't
it's-
we see?
Huh?
See, there's a bit of a nuance to it. What you
Dude,
went on to explain how a
you're out to
circle
lunch.
works on a wall got taken to school by an engineer.
You got no
after
argument,
me.
buddy. You got no argument.
And
so again,
you still have to
Anonymous-
explain what the moon is doing, not your wall and your circle and your bullshit. Can you go back to answering the original question? How is
Anonymous
it possible on a flat Earth?
Anonymous asked me, how do you see different sides of the moon? That's what she asked. I gave her a practical example. The other guy stepped in. He says, no, because it would be oval shaped. And I said, no, if you have a high enough ceiling and you're not far away and you're at the right angle, that circle will appear to be a circle for all observers, and you will be able to see different sides of that circle. That's a fact. You can go check yourself.
Not a fact. You can measure it
Now
to be
they're
an
gonna get
ellipse.
super triggered. Everyone talk at the same
How
time.
far away the moon would have to be to make that make it appear as if it was a circle from every direction, even if it wasn't a perfect circle? Can you give us an idea of how far it would have to be?
What, are you in a cave?
Are you telling me to tell you to measure a circle and the size of it and how far an observer have to be for it on the floor?
I'm asking you to follow your implications to their conclusion. So if you're saying that the moon is far away enough that it can be flat still, a flat circle, and still appear like a circle.
So I never said the moon's a flat circle.
He never said that.
Then why are you arguing that it's not a sphere?
So they asked me for a demonstration to see how you can see a round circle in sky and see it from different angles and see different sides of it. I gave you a demonstration of that you can do. Now you're trying to obfuscate because I used a piece of paper. Give me a break, bro. I'm just showing you that you.
Your demonstration is false.
You can have it all false all you want. The point is the demonstration is there and it does work.
No, because we use your demonstration to show perspective by measuring the amount elliptical that circle becomes when you move to the side.
So do you listen to what you say, bro? You just told me that at an angle from the observer, eventually it will go from oval to circle. You just said it.
I did not. You've misquoted me on that multiple times. I've said
Okay,
it gets
so-
closer to a circle, but it continues to be elliptical unless you were perfectly on axis.
So it gets closer to us.
When you just said you weren't arguing this, you just said you're not arguing that it's flat. So you're not saying the moon's flat. Then why are you arguing that it's flat?
So again, I'm giving you a practical example to see different sides of a circle. That's all it's about. She wanted to know how to see a circle in the sky from different points of view showing different faces. I gave you a practical example for it. Buddy says no, because it would be oval. I said no.
Your practical example is literally the same practical example that is used to disprove what you're saying.
Sure. So then it gives you what you need for an answer, whether or not you have the right ceiling or the right.
You're clearly confused by what the answer should be.
So let's put it this way. Let's say I'm standing. I have I'm right in the center of my room, and I look directly up. Okay, and I see a flat circle. Now I step back 3 feet, and I get everybody to step back 3 feet. We look up. We're seeing a circle. You can see different.
Side of you are not going to see a circle.
You are no longer
People
seeing a
on
circle
either
when you
side
step
of you-
back.
And people on either side of you won't be seeing a circle.
The angle is not narrow enough to cause the oval shape at this point. Now, if I walk away, if I keep walking away and we all walk away and the ceiling is not high enough, then yeah, the circle will turn into an oval. Granted, I agree with you. But like I said, you can demonstrate this by getting closer. You can get closer to the circle and look up.
How far away would you need to be, given the size of the Earth, either side of it, two people on two ends of it, be able to see this object that you're now saying is flat on the ceiling, this moon? How are they able to see this object always appear to be a circle? How far away would that need to be?
How far would the moon have to be? We have no idea how far the moon is. What are you talking about?
Yeah, but
250,000.
This is all also assuming it's physical. It could be some sort of like holographic projection. Or
Hey, you know what,
hologram.
Nathan? I got a good.
It's literally
I got a
obviated by
good
results.
formula for you for this particular thing. It's actually quite fascinating. Do you know who Dr. A. Wilford Hall is?
No.
So he came up with the a calculation in early astronomy, or basically broke down the calculation from early astronomy, calling it perspective point. It's quite interesting because if you take the apparent size of the moon shadow that as it transverses over Earth, which is like 75 miles or something, right? 70 miles. If you take this constant he developed, which is 3,000, and you times it by 70 miles, you get 210,000 miles away, right? But here's the thing. That's on basic perspective point, so a vanishing point calculation. The moon hasn't vanished at that point, is it?
All right.
So it's quite interesting anyway. And this calculation was used for early astronomy. So it's taking the angle of view, which is the angle of your cone of vision, and then dividing it by your maximum angular resolution of 0.2, and you end up with this 3,000 constant. So take the diameter of any object, times it by 3,000, you'll get its perspective point. In other words, a quick calculation for the Rayleigh, another version of the Rayleigh criterion. But it's odd that I can get modern science's calculation to the almost. I'm at 28,000 miles off, but at the end of the day, you can see the moon is clear as day, and it's not vanished into a point. So I must tell you that the perspective calculations here on Earth, terrestrially, are calculable, but if you apply it to the heavens, extraterrestrial, the calculations don't fly. And that's what leads me to believe that the moon is not a solid object.
Yeah, and their whole argument is like, it's physical. It would turn it into an oval as it goes away from you. And we're like, no, guys, it's not what it is.
And this is actually using early astronomy's mathematics, and it's quite fascinating, man.
But yeah, you got there doesn't hold for what you started with.
The phrase I use is
I don't get a chance to talk to Nathan that much. I don't know. He's got the memory of an elephant, so if I could feed him that, it might lead to something else.